Just 1 minute.
Yeah, 1 minute more.
Hello, Dr.
Yes, sir.
Yes.
Dr. Das, Madan sir wants to talk with you.
Yes, sir. Sir, Madhun sir, are you telling something? Madhun sir?
I was trying to say hello to Guha.
Yes, I'm hearing.
Yes.
Yeah. Hello, how are you, sir?
He seems very busy.
Yeah. Madhun Sahab, namaskar.
Namaskar, how are you?
Fine.
Okay.
What about you?
Good. I believe good.
Okay.
Sir,
Thank
now
you.
we are going to start. Okay.
Yeah, all are requested to mute their microphone.
Please.
Good afternoon to you all. I am Dr. Propal Ranjan Ghosh, Associate Professor from the Department of Veterinary Physiology, Faculty of Veterinary Animal Sciences of West Bengal University and Fishery and Animal Sciences. West Bengal University of Animal and Fishery Sciences. My greetings and good afternoon to all. I am conveying my best regards to all the honorable dignitaries, respectable faculties, scientists, teachers, dear research scholars, postgraduate students, ladies and gentlemen. We are overwhelmed by your gracious participation in 3 days online national workshop on climate smart livestock production in India. It is starting today and will continue up to the day after tomorrow, and hope you all will enjoy the workshop. I am thankful to the organizers and really feel proud to conduct this session. This workshop is a humble initiative by the Department of Veterinary Physiology under the Faculty of Veterinary Animal Sciences of West Bengal University of Animal and Fishery Sciences, Kolkata. In these difficult days, when every nook and corners of this beautiful planet is suffering from COVID-19 pandemic, we organized this workshop on a very pertinent topic on climate change. Some stalwarts in this field spared their precious time and shared their valuable thoughts with us. Climate change is one of the greatest threats to global security. Climate change knows no borders, and it presents an existential challenges to us. That is why it is so important that we met here today. Climate is robust to explain and very complex, encompassing about all the biota and non-living world of this planet. In this workshop, we will focus only on its effect and smart mitigating measures in relation to livestock production. Now, I am happy to announce in the inaugural session, we are having with us Professor Chanchal Guho, our Honorable Vice Chancellor, West Bengal University of Animal and Fishery Sciences, Kolkata, and requesting him to chair the session. Sir,
Thank you.
it's a great pleasure to inform you that Dr. M.L. Madan, a revered personality in the field of veterinary and animal sciences since more than half a century, is with us. And I'm requesting him to kindly be our chief guest, sir. I'm also elated to invite Professor Arunasis Goswami, Director of Research Extension and Farms, and Professor Nilotpal Ghosh, Dean Faculty of Veterinary and Animal Sciences of our university, to kindly present as a guest in this session. I personally, and on behalf of our university, welcome you, sirs. With the permission of the chair, I am starting the inaugural session. Now I am requesting Professor Pradeep Kumar Das, Head, Department of Veterinary Physiology, and Program Coordinator of this workshop, to deliver his welcome address and brief speech. Professor Das, please.
Good afternoon, respected Vice Chancellor and the Chairman of the session, Professor Chanchal Guho sir, respected Professor M.L. Madan sir, Professor D.N. Kamra sir, Professor Sagar Sennal, Dr. V. Sejian, Director of Research Extension and Farms of our university, Professor Arunasis Goswami, Dean, Faculty of Veterinary Animal Sciences, Professor Nilotpal Ghosh, all the teachers, officers, students, and staff of the Department of Veterinary Physiology and of the university, and the enthusiastic participants. I, on behalf of the Department of Veterinary Physiology of West Bengal University of Animal and Fishery Sciences, welcome to all of you for participating in 3 days national workshop on climate-smart livestock production in India. Presently, our department has 5 teachers. We feel proud to become a faculty of such an institute which had a glorified century-long existence. The origin of our university is on the base of establishment of Bengal Veterinary College in the year 1893, the then second oldest veterinary institute in India after now. We have some eminent ancestors like Dr. B.P. Sadhu and Dr. A.K. Chaudhuri and many more. We are regularly organizing hands-on training, workshops, seminars, utilizing our state-of-art laboratory and the modernized video conferencing unit. Considering the burning issues of the society, we select the present topic of discussion in the form of a 3 days online national workshop. Livestock is the basic source of income of about 21 million of Indian people. Further, there are many people where livestock becomes the primary source of income when agriculture suffers due to several disasters. Considering this, livestock directly contributes the livelihood of nearly two-thirds of Indian population. It also supports nearly one-third of their dietary protein. So, livestock production is directly related with the food security, particularly the child and mother nutrition and health. Its importance has been increased many folds in COVID pandemic situation. Now, livestock farmers are facing so many challenges in this century. One of the important hurdles is to sustain in changed climate situation, and India is considered as one of the declared 27 such vulnerable countries of the world. Changed climate not only causes natural calamities, it is also shifting the genomic characteristics of the pathogens and the vectors as well, along with severe crises in feed and fodder. It causes serious ill effect in nutritional status of the animal and altered physiological system to different stress. On the other hand, FAO already announced at the beginning of this decade that adoption of climate smart agriculture CSA with the advancement of technological development can be the solution to combat the challenges. Various researches and experimentation are continuing to enhance resilience in climate smart scenarios. It is very vulnerable in perspective of climate smart livestock production circumstances as India belongs to largest number of livestock in the world. ICR has undertaken various national initiatives. Various dietary and reproductive manipulation as well as management strategies have been adopted since last 1 decade to afford the productivity of the livestock. Considering this background, we have planned to organize these 3 days national workshop. The stalwarts of all generations in the field of veterinary physiology, like Professor M.L. Madan, the former DDG Animal Science of ICR, Dr. Bishi Das, Principal Scientist of ICR NRC on pig of Guwahati, Assam, Dr. V. Sajian, Senior Scientist, ICR NINP Bangalore, Karnataka, and Dr. D. Banerjee, Assistant Professor of the WBFS Kolkata, will deliver their experiences. I hope the expectation of the participants will be fulfilled, sharing with such personalities. It is our great opportunity to get the blessing from Madan Sir, who is famous by his name. He is also the chief guest of our inaugural program. I welcome all of you, sir. We have another stalwart, Professor T.N. Kamra, ICR National Professor, Division of Animal Nutrition, ICR IVRL Berili of UP, who has limitless knowledge in the field of animal nutrition. We will enrich various mitigation strategies about the greenhouse gases in the perspective of climate-smart livestock production. I welcome Professor Kamra, sir. We have a distinguished scientist in the field of animal genetics, Dr. S.N. Dev, Head Division of Animal Genetics and Breeding, ICR NDRI Karnataka. He was also the former director of ICR NRC IAC of Viran, Arunachal Pradesh. He is also the chief guest of validatory program. Our knowledge will be upgraded from Dr. Dev, knowing various breeding and biotechnological advancement in livestock sector to adopt the climate stress. Modifying management practices of the livestock is one of the key ways of the climate smart resilience livestock production. We will be learned the strategies in this regard from Professor L.K. Babu, the Dean of College of Veterinary Science and Animal Husbandry of OUAT, Odisha. I welcome our beloved Vice Chancellor, Professor Chanchal Guha sir. Without his continuous inspiration, this program cannot be organized. His Sir will deliver his valuable talk immediately after my speech and will also inaugurate the workshop. I also welcome our Director of Research Extension of Farms of our University, Professor Urunasis Goswami, the Dean Faculty of Veterinary Animal Sciences, Professor Nilokol Ghosh, and all other officers, all the teachers of the department, supporting staffs, our colleagues, students, and all the well-wishers who are helping in different stratum for the organizing this 3 days workshop, including the Google Meet and YouTube platform. Lastly, but not the least, I welcome all the fervent more than 700 participants, including abroad. Due to large number of participants and connectivity constraints, we cannot afford space to all in Google Meet platform. Most of the participants are joined with us in YouTube live streaming media, but it does not make any effect in the spirit of the workshop, as all the participants can participate in the interaction program with the speakers only through the chat box, whatever may be the Google Meet or YouTube. I also appeal to the participants to cooperate with us to organize the 3 days workshop, having 7 sessions with a pre-inaugural and valedictory program. All the speakers are participating from remote places, hence connectivity problem may arise. Please bear with us in such circumstances. Hope we can get a positive directive from the workshop which can pursue our future guidelines in a climate-smart livestock production scenario in India. Thanks to all.
Thank you, sir, for your address and present the theme of the workshop in nutshell. You rightly pointed out the importance of this workshop. Thank you, Professor Dash. Now, I feel proud that Professor Chanchal Guho, our Honorable Vice Chancellor, is with us. He's an excellent academician, brilliant researcher, and above all, a fantastic teacher. He mentors 24 masters and 9 PhD students in the field of preventive veterinary medicine, and also contributed in different fields of our international in the different fields since the last 4 decades. He published more than 100 research papers in national and international journals. Professor Guho handles several research projects funded by iShare, DST, DBT, and RKPY. Professor Guho contributed significantly for the development of attenuated ND vaccines. He also handled internationally funded project on tuberculosis. He has several awards and fellowship. Without his enthusiastic support, motivation, and encouragement, the organization of this workshop cannot be hatched. We are greatly thankful to you, sir. Hope your blessings will continue in future. Sir, I am requesting you to share your valuable thoughts on this aspect. We are eager to hear your talk. Sir, please, Professor Ghosh, please.
Well, good afternoon, everybody. Now, I'm really very happy to be here as because this is a nice program. This is being a 3 days seminar, this workshop, which is entitled on this climate smart livestock production in India. But this we are very much aware of this term, this climate, this smart agriculture, growth and agriculture. But this is a new term, of course, not new term. It has been here since 2015, but it has not been grown, that has not been developed yet. It's too far. But I must appreciate and congratulate Professor Pradeep Das and his team to this conduct such type of workshop, which will give us a new idea in relation to this seminar, but after this completion of this seminar. Now, I must thankful to Dr. Madan as because with his busy schedule, he is being here with us. And I'm sure that his knowledge and his experience and he will share us with a lot of these things in relation to this topic, and so that we can enrich ourselves for the further development of our profession or for the further livestock development. Now, at the same time, I must convey my regards to Professor Sagar Shanal. He's my teacher, and I'm very much happy to be here as because he is here to hearing this dialogue or this lecture. And others, our Dean, Dr. Nilokol Ghosh, our Director of Research Extension Farm, Professor Urunasis Goswami, and the other dignitaries and the teachers, member of the faculty, as well as different participants are attending this program. Now, the concept of this climate smart livestock development. Now, if we think of that this total livestock production, what is prevailing right now, is not up to the mark which can fulfill the requirement which is being required right now. But now the right moment that we are having this total 9.2 billion, this population in the world, human population, and it is expected to be this 9.1 in 2050. But considering this population, we have to go for the growth and development of this agriculture as well as the livestock development. Now we are thinking since 2010 about this development of the agricultural growth, but we are not much aware of the growth and the development of the livestock. That's why I once again congratulate this team who are organizing this type of program or this seminar on the topic of this climate smart livestock development in India. Now you see the different the adverse situation which is interfering the growth and development of the agriculture as well as for the growth and development of the livestock. But just to maintain and just to overcome this situation, we have to mitigate the problem which is right moment is required for the proper development of the livestock. But if we consider about the different stresses which are going on, which interfering the growth and development of the agriculture, as well as it is interfering the growth and development of these livestock. But we have to mitigate all these problems, and that is the need of today, how we can develop this livestock and how we can fulfill the need of the population, because that is being recommended by this FAO that about 60% of the production is to be increased just to meet up the requirement what is required at the 2050 just to fill up the need of the food of the total population, that is 9.1 billion. Now at this moment, I'm not going in details about this subject because there are a number of these experts, they will talk on this topic. But right moment, I must talk something about our state, that now we need to prevail certain genetic makeup or certain animals which are very, very, very easily, which can harbor, which can be the habitat or the habitation of the animals of the genetic makeup, which can nicely grow in the state like West Bengal. We are blessed at that sense that we are having 3 breeds of these animals. That is the first one is the that is our Black Bengal goat is a very, very pioneer of the breed of this state, as well as the another one is the Garol sheep and this Ghungru pig. So these are we are the blessed of these three breeds because they are having the genetic makeup which can harbor very nicely, which can meet up the need of the state at the same time, which can meet up the need of the country as a whole. So we are trying to, because these are there some of the breeds, particularly for the Ghungru, and this breed is almost in the endangered stage because that is in threatened stage. So we have to take much care for the maintaining of this strain of this species of this animal or this breed of this animal, because which is very, very important because its need is much, as because it is having a very good quality of pork. At the same time, its proliferation rate is very, very high, and at the same time, the pre-weaning mortality of the piglet is very, very less in this particular Ghungru breed of pig. So we are trying, or we should try to maintain this breed, and which should mitigate this problem right now, which is related to the pork and pork production. And at the last, I must talk something about this department. It's a very, very old department in our faculty. And this Professor D.P. Sadhu, he is the renowned scientist, and there are a number of these students which is being taught by him, and now they are roaming all over the country. Not only that, all over the world. And he's a very, very prominent and solid and knowledgeable teacher, and he taught number of the students, and they have developed in their own way for this profession as well as for their scientific field. And at the same time, this department right now, they are handling different these projects. Particularly now, they are very much habituated, or they are working on this adaptation of this Black Bengal goat in this Sundarban Delta. At the same time, they are doing some work on this germ cell or this, and there are different non-invasive diagnostic aids they are using, like this ECG and this ultrasonography and other tests. At the same time, they are very actively involved in these academic programs. Overall, I must congratulate to the team once again, as because they are organizing such type of nice this workshop at the same for these 3 days, and the number of participants, about more than 300 participants, will attend this program. So I think they will enrich their knowledge and they will learn a lot, which can help in future the climate, this particularly the climate smart livestock development in the country. Thank you all.
Thank you, sir. You nicely described the bits, the problems of our states. And I'm thanking you for your excellent speech. We, all the participants, are enlightened with your vision. Your insight will certainly guide us in future. I convey my best regards to you, sir. Thank you, sir. Now, I am humbly presenting Dr. M.L. Madan, the distinguished chief guest of this session, and an alpine personality not only in the field of animal physiology, but also in veterinary and animal sciences as a whole. He is a man of national and international repute. Professor Motilal Madan is a distinguished veterinarian, agriculture expert, animal biotechnologist, academician, and research manager. Dr. Madan obtained his bachelor's and master's degree from Punjab University with flying colors. He got gold medals both in BVSC and MSc in animal physiology. Then he pursued his PhD from University of Missouri, Columbia, United States. He has been honored with the degree of Doctor of Science, DSc honoris causa, by the University of Guelph, Canada in 2012. University of Guelph is the oldest and most prestigious veterinary institutions in North America. He has also earlier received DSc honoris causa from University of Agriculture and Technology, Kanpur in 2001. He served in different key positions in the elite institutes and organizations of our country and abroad. Dr. Madan has been Vice Chancellor of University of Mathura, Vice Chancellor, Agriculture University, Akola in Maharashtra, Deputy Director General, ICR, Joint Director, Research and Project Director, Biotechnology at NDRI. He established the Division of Physiology and as head of the division, took the research and teaching to new heights as testified by excellence in publication and students' performance. Dr. Madan has also been a United Nations and FAO and UNDP consultant. In a short span of time, it is not possible to describe his checkered personality. We are very much thankful to you, sir, and extremely grateful that you spare your valuable time with us. Sir, we are eager to hear from you. Now I am requesting Dr. M.L. Madan to deliver his lecture. Sir, please. Dr. Madan, sir.
Sir, please unmute, sir.
Dr. Madan, sir.
Madan, sir, please unmute yourself.
I hope
Yes,
I am audible to the group.
Yes, sir. Yes.
Yes, sir. Thank you, sir. Oh, it is audible.
Thank you very much, Ghosh, for making that introductory remarks, which go back to the times when I have been a colleague and worker along with all you. And it's a pleasure for me today to be joining you all here
So it's,
in this afternoon for a very pleasured session also. At the outset, it's a pleasure to be welcoming Professor Guha, and who had some very nice, kind words to say. Thank you, Dr. Ghosh. And again, it's a pleasure to be addressing this group, which includes Professor Goswami, and we have got Dr. Kamra, who is an outstanding animal scientist. We have got also along in there Dr. Sejan, we have got Dr. Deb, Dr. Khan, and a variety of other groups and people, including our deans of education and farming, as well as the director of the research at the West Bengal University of Agriculture and Fishery Sciences. And also that I'm very happy to have heard the introductory remarks of the Vice Chancellor when he mentioned about two things, which I would like to recite and recite with celebration. And one was the name of Professor Sadhu, D.P. Sadhu, who was an illustrious animal physiologist. As a matter of fact, that one of his students has been my mentor, who was here at the National Dairy Research Institute when I was in here, in the name of late Dr. Rajdan. And also that I'm very pleased to mention, very pleased to listen, the mention he made about the two specialized breeds of livestock in the West Bengal, the Garol and the Black Bengal, which have gotten special affinity to a particular type of climate. And to start, I think this is the point I would like to introduce, that when several decades back, we tried to have these Garol sheep out from the locale of West Bengal over into the arid and rather hot in Maktoum, in Avikanaga. At that time, that there was a lot of resistance. But today, the Garol sheep have worked wonders with that institution and worked wonders with the art of breeding, as a matter of fact. And I dare say that there is no animal science genetic gain which is manifest on the ground and proved through technological assessment to be as valid, as genuine, and as forthright in terms of scientific fit, giving benefit to the farmers, than the work which has been carried out with Garol sheep there at Avikanaga. And that is an introductory word, I would say, about all what we are talking about, the challenges of climate change. Here was an animal which had a change in climate, but then we know today that going back to the thousands of years, the climate has been changing, and so has been the livestock, and so has been the man and animal. And in that process, if we start to have a dialogue between a man and an animal and try to find out that how this process of climate has been affecting them, it's a very interesting and very long tale. And as a matter of fact, that at any single point of time, we can't say that climate has not produced its effect. But at the same time, we must realize and accept this fact that whenever we are talking of climate change happening at a point of time, we are also conscious of the series of evolutionary changes which are supposed to be taking simultaneously. So as a matter of fact, that taking climate in isolation may not be as accurate as talking of the ecosystem in totality and finding out that how the evolutionary changes have been affecting or are affecting our systems. Animal system in the developing countries particularly is changing very rapidly in response to the variety of drivers. These changes, I believe, bring about qualitative and quantitative transitions in the production system due to a series of transformations and disruptions occurring sequel to the technological advances, the climate change, socio-economic compulsions, demand of agricultural produce demands, and human and animal health, the biosafety considerations, rural-urban divide, and also other things, for example, the income disparity, land fragmentation, and the food preferences. Now, if you take all these things, you can see that our canvas gets so large in identifying that where really we are with respect to the livestock production and these transitions through which we are going at present with respect to demands both in the developed and the developing countries. And the interesting thing is that 45% of economic returns, GDP returns, the world over today all from in the area of agriculture or from livestock. Even in India, that where we officially are saying that it is 31 plus 5, 31 plus 5.5, which comes about the 36.6 as the contributions which livestock makes, livestock and fisheries together make towards the agricultural economy. In fact, we have states in which these contributions go as high as 47 to 48%. And very interestingly, in those states where the contributions from livestock are very high in the agricultural GDP, the poverty in those states is the least, minimum. And in states where the contributions from livestock to the agricultural economy is very low, we find that the poverty is high. I don't want to identify the states right now, but it's very clear that if you take the look of what's happening in Punjab, Haryana on one hand, and what is happening in Orissa and Bihar on the other hand, you can very well see that Haryana today about 46% contribution which come from the livestock, and that's how. And Punjab also it is 44.5%, and that's how we see this transformation which is occurring. Now, once we are accepting this transformation is happening, we at the same time have got a climate which is overriding these influences. We have seen that there is a change in temperature, which I will be elaborating during my subsequent talk. But there are several drivers which lead us to this. And it is the system totality, that's the agricultural system in totality, which leads us to these drivers. And over the past decades, there are difficult times which have come. And I'm certain that the system itself is dynamic. If we can survive this endemic Corona-19 as of now, I hope that we'll be able to survive these difficulties which we are having with animal production. The challenges are tremendous. And we will be going over in delineating that what are the challenges, how we have to meet each of them. But just to mention as an introductory thing, in the Indian context, that climate change is inducing an additional stress to the ecological and the ecosystems as they are already under a tremendous pressure for various reasons, including increasing population, unplanned urbanization, industrialization, and associated activities. The natural resource-based economy makes India as a nation all the more vulnerable to these changes. And this vulnerability of India with all the things which I have mentioned earlier makes a special occasion for us to be celebrating this type of an gathering, this type of an scientific get-together which we are having together. I'm so happy that Dr. Das has been able to group in people. I see Dr. Sejan in here, I see Dr. Das in here, and Dr. Kamra in here, that who are the leaders in their own sphere. And all of them have contributed significantly, and we'll be hearing from them as part of this discourse. Also included in this is young people that about 300 of them whom I'm told have registered, that I'm sure that this workshop will be providing them with certain hands-on, if not with their own hands, but at least demonstrating to them that what are those things by which we can talk of improving our production system, livestock production system. One word which I would like to introduce at this stage itself, though I'll be going in greater details, is that we are talked this seminar as climate smart. This climate smart word needs to be understood. That where is and what is that smartness we are looking into, and how we have to deal with this smartness. I was talking to Professor Das, and he was invited me over for this get together and scientific powwow with the community. At that time, I made home to him that the importance of this, the sensitivity in the word smart, and where this smartness has to be. The smartness is the climate to be made smart, or it is the animal, or it is our management which has to be smart. In fact, it's not one, but it's all the three, of which I will be elaborating a little later. With these words, I hope that I have had my time, and for me, it's a pleasure to be involved in this inaugural conference. And I'm thankful to Vice Chancellor Goha for having provided me this opportunity to be with you and to be speaking to you. And I'm also thankful to the organizers in here for this mighty opportunity when we're all locked down in our homes to be face to face with people and talking to people and exchanging our thoughts with people, something which is very near and dear to my heart. Thank you very much.
Thank you, sir. Actually, your brief and erudite address is simply awesome. Your inaugural talk entails us the need of the hour to build climate-smart livestock production system. Your vision and deep thoughts will certainly guide and motivate us in future. Your elegant speech instilled passion and will stay long in our remembrance. We all will sit tight to hear your main lecture in the next session, sir. Very many thanks to you, sir. And thank you, sir. Now, I'm requesting our special guest, respectable Professor Arunasis Goswami, Director of Research, Extension and Farms, and Professor of Veterinary Extension of our university, having more than 30 years of work experience. He handled 9 projects funded by ICR, DBT, DST, RKVI, etc. He received about 10 honors in terms of awards and fellowships. He has 215 publications as research papers, including books. Sir, your enthusiastic support and suggestions are indebted. I am requesting you to share your valuable thoughts to us. Sir, please. Professor.
Thank you, Dr. Ghosh. Good afternoon, everybody. Honorable Vice Chancellor, Professor Chanchal Guha of our West Bengal University of Animal and Fishery Science, Honorable Professor M.L. Madan, former Deputy Director General Animal Science of Indian Council of Agricultural Research, Government of India, Professor Nilotpal Ghosh, Dean Faculty of Veterinary and Animal Science, Professor Sagar Channal is my teacher, Professor P.K. Das, Pradeep Kumar Das, who is the head of the Department of the Veterinary Physiology and the coordinator of this program, Dr. V. Sejian, Dr. S.M. Dev, Dr. B.C. Das from Guwahati, Dr. D. Banerjee, Deepak Banerjee, Professor L.K. Babu, Professor D.N. Kamda, and all other team members of Professor Das, Dr. Kobal Ghosh, Dr. Kinshuk Das, Dr. Jaydeep Mukherjee, Dr. Omlan Patro, and all others. Practically, to be very frank, I am feeling shaky to share with this dais along with Professor M.L. Madan sir. Because in the year 1986, when I was a student of IVRI in MBSc in Extension Education, I met him at NDRI. So, sir, it is very, really, I am telling from my core of my heart, I am feeling shaky to share, being your student, to share with you in this dais. So, thank you, sir. At least this pandemic COVID-19, whatever it may be the negative effect, for me at least one effect that I could meet my teacher after long back in this digital platform. So in other way, however, sir, I am really thankful to Dr. Pradeep Das. He has given me the chance to share this dais with this long stalwart of animal physiology, not only in India, across the globe. So this 3 days national workshop, the climate smart livestock production in India. So actually, sir, I am a man of veterinary extension. So 3 things are here which I can share with you. That climate, another is livestock, another is production. So for production of livestock, so many other attributes or parameters are required. That may be the technology, not only the technology, availability of technology, accessibility of technology, marketing, consumerism, and the socio-economic status of the consumer. And along with the other things, the diversified climate, it has the pivotal role, especially for the production. So I don't know, the technology, we have advanced in even developing country like us in animal technology related with the production, whatever we have already developed this technology, whether we are in a position to adopt all those technology or to disseminate those technology to the doorstep of our stakeholders. So that is one question. We have done, somewhere we have done, but not everywhere. But we have to do something. But within this coming 3 days lecture session, all the stalwarts will be there, and they will be discussing on the specific, the salient point, that is the parameter is the climate. Because the climate, it has having so many effects on production, not only the reproduction, also on production. And in this pandemic situation, we are now concerned with two things. One is life, another is livelihood. So life is being dealt with some other sister part of our concern, that the human doctors. But we are not, being the veterinary doctor, not only we are concerned with the clinical, but also the productive aspect, and which are directly related to the livelihood of the stakeholders, of the country, of the huge population. So if we want to secure our livelihood, then we have to enhance our production. And if we want to enhance our production, we have to take the help of the advanced technology, and it must have to be the climate resilient. And that's why it's my just humble submission. After coming this 3 days deliberation, whether we in a position to draw a digital map depending on the different climatic situation of our country, or statewide or district-wise if possible, by which we can give the advice to our stakeholder. So this is your place. This type of technology, this type of species of animal can be reared, can be economically viable, and this type of technology is available. So whether we are doing the area specific, not only the feed, not only the fodder, but all sorts of technology, whether it is area specific, climate specific. So if we are in a position to draw or something like this type of atlas, the livestock farming atlas, by which the veterinary surgeon who is posted in the field, they can also take the help of that atlas and they can guide the stakeholder. So this is the thing, this thing you can do. So this is my humble submission to this August platform. Hope this 3 days discussion will be given by the stalwart in animal physiology, not in the country, but in the globe. So this seminar, this workshop will be very much fruitful to the all people, not only the policymakers, but also the students, research scholars, and even ultimately to the stakeholder of our cross-section of the society. So I hope this fruitful discussion will be very much meaningful, and it will be helpful to mitigate the crisis, especially during this type of pandemic COVID-19 situation. And above all, lastly, again, I would like to convey my sincere thanks to Professor P.K. Das to organize such type of meaningful and need-based program of the country, and to allow me to share with the dais with my teacher after long, at least more than 35 years. Thank you, sir. Thanks, everybody.
Thank you, Professor Goswami. Actually, your suggestions, thoughts, these are excellent. And I think all this within the 3 days, we'll discuss all the parts which you actually raise the questions in, that will be discussed in a very wide manner. And we really cherish your scholarly address. I hope your support will be in future too. Now, I'm requesting Dr. Nilotpal Ghosh, Professor of Livestock Production Management, and presently working as Dean, Faculty of Veterinary and Animal Sciences of our university, to deliver his address. Professor Nilotpal Ghosh, contributed significantly in the field of livestock production management. He has meritorious academic performance, obtaining first-class first position in both BVSC and H and ABSC exam. Professor Ghosh is an excellent teacher, having about 30 years of experience. He has in his credits 54 research articles, 5 book chapters, and 16 professional books in the field of animal husbandry. He has guided 3 PhD and several PG students. We are thankful for his all-along support to make this workshop a successful one. We are anxiously waiting for your valuable address, sir. Sir, please, Professor Ghosh.
Thank you, Dr. Ghosh, for your nice introduction. Good afternoon, everybody. We have with us a galaxy of scientists and educationists with us. We have with us our Honorable Vice Chancellor, Professor Chanchal Guha, sir, our Director of Research, Extension and Farms, Professor Onosis Goswami, and we have with us world-famous animal scientist and former DDG Animal Science ICAR, Professor M.L. Madan, sir. Besides this, we have with us Professor L.K. Babu from OUAT, Dean College of Veterinary Science, Professor Kamra, National Professor in Animal Nutrition of IVRI, Dr. S.M. Dev, our senior from this institute, who is the principal scientist and head of AGB division of NDRI, Dr. B.C. Das, principal scientist of NRC PIG, and many more dignitaries in this program. On behalf of the Faculty of Veterinary Animal Science of this university, I convey my thanks and regards to all the dignitaries and also to all the participants who enrolled for this 3 days workshop. And actually special appreciation also due to Professor P.K. Das and his team from Department of Veterinary Physiology of our faculty, and who happens to be my classmate also. I am proud of him for organizing such type of programs in the banner of our university, West Bengal University of Animal and Fishery Sciences. Actually, organizing such type of programs during this COVID-19 pandemic situation make us live in our professional life. The theme and the title of this workshop is Climate Smart Livestock Production in India. Actually, this livestock production is an important subsector of Indian agriculture. We know there is a huge contribution from this livestock sector to the economy of India. During a few decades, about 4% of the GDP, gross domestic product. Now it is called, instead of GDP, it is called GVA, gross value added. Actually, during the 2017-18, this contribution is to the tune of 4.9%. We have seen that contribution of agriculture to the national economy is in decreasing trend. Now it is only 10% to the national economy. But contribution of our sector, livestock sector, to the agriculture is in increasing trend. Actually, this is about 28.4% of the agricultural contribution at present in the year 2017-18. So there is a huge contribution, and we have vast resources in livestock also, as per the last livestock census 2019, 20th census in the series. We have huge number of livestock, 53 crores of livestock and 85 crores of poultry. And with this livestock population, we have a sizable population in the world contributing 11.6%. So with these livestock resources, we should use these resources as our opportunity. Our genetic diversity is also very rich, having 197 recognized breeds, including 50 number of cattle, 44 number of sheep, 34 number of goat, and like this. And the share in case of buffalo population is about 58% in the world. We are at number 1 in buffalo population. Second position is in cattle and goat population, and third in sheep population. That is, with this huge livestock population, we are producing a lot also. India continues to be number 1 in milk production, producing 187.75 million tons. And with this production, our per capita availability raised to 394 gram per head per day, which is more than the ICMR recommendation of 300. Though regional disparity is there, Professor Madan said rightly that in Punjab and Haryana it is 1 kg per head per day, but in West Bengal it is only 158 gram per head per day. Regional disparities to be reduced somehow with our activities. We are also progressing in poultry sector and meat sector, which is remarkable progress. And this livestock production, Professor Orunashis Goswami rightly said that it plays a remarkable role in the livelihood security of our rural masses, contributing subsidiary family income, generating their livelihood, and this employment, gainful employment, and also their family nutrition status of the farmer's family can be enhanced by allowing some domestic consumption of livestock products. Now, with this huge livestock population and diversity, we are also confident in livestock production system in our country. But we have also seen that this livestock production is being severely affected due to global warming and climate change. The direct effect of the global warming and climate change is seen in health, reproduction, nutrition, and which results in poor performance, low quality animal products, and outbreak of several diseases. So we have to do our research work in this way to mitigate these programs we are doing, but we have to do more and more to standardize these mitigation strategies. Now, this is one side. There is a great impact of climate change on livestock, but it is also true that our livestock is accused of being the major contributor of global warming by releasing several greenhouse gases. And in one report, it is seen that about 12 to 18% of the total anthropogenic gas emission is from livestock side, out of which we are contributing from livestock 5% of the carbon dioxide, 44% of the methane, and 53% of nitrous oxide. So we have to be concerned about this also to reduce the greenhouse gas emission from our livestock side. And especially it is seen that this emission is particularly due to enteric fermentation of our ruminant, the manure of livestock, different types of livestock, and also the livestock feed and fodder production, processing, and transport. These are the main issues from where these gases are being released. So we have to be concerned about this, and hopefully all these aspects will be dealt in detail during this 3 days workshop. And I wish that all the participants will enjoy this workshop from your home and stay safe. Thank you all.
Thank you, Professor Ghosh. Thank you, sir. Your smooth and valuable address is great. And actually, all your suggestions and everything which you have given will be taken care of, I think, by the speakers in their sessions, particular sessions. Now, the inaugural session is going to be it. I personally, and on behalf of the organizers, convey my heartfelt thanks and regards to all the revered speakers of this session for the cherishing address. And I'm also very much convey my regards to all the speakers of the different session, like Professor Kamra, Professor Dr. S.M. Dev, Dr. Sejian, and Dr. B.C. Dash, who are with us, and also all the senior dignitaries, Dean of the Fishery Faculties, Dr. Bipul Kumar Das is also here, Dr. Subhasis Botobel, Dean Students Welfare of our university, and all the participants. I think they are really enjoyed this brief session. And before this thing, all the speakers are stalwarts in their field, and all actually excellently delivered their thoughts to us. So I'm very much thankful to you, sir. Professor Madan sir, we are eagerly waiting for your lecture in the next session. So I'm not, due to constraint of time, already we are running late. So with the permission of the chair, I am declaring the session is over. Thank you, sir. Now, the exciting second session will be started soon. I'm requesting Professor Pradeep Kumar Das, Head Department of Veterinary Physiology and Program Coordinator of this workshop, to conduct the upcoming sessions. Professor Das, please. Thank you.
Thank you, Dr. Bose. I again convey our
So, Dr. Das, please. So, Dr. Das, please, may I take leave
Yes.
from this session? Okay.
Yes, yes,
Okay. Thank you.
Thank you,
And once again for the nice contribution as well as this organizing this program. Well, thank you all.
Thank you, sir. Thank you, sir.
Thank you, Dr. Das. Thank you.
Okay. Thank you. I just want to introduce the speakers of the other sessions who are present here today. Professor Kamra, sir. Sir, just please tell just 1 minute, sir. Professor Kamra, sir. Yes, sir. Just unmute, sir. Unmute yourself.
Yes, sir.
Yes. Professor Kamra, sir, he will talk on the third session, tomorrow morning session, with the speaker of our workshop. Yes, sir. Then Dr. S.M. Dev, sir, is here. Yes, sir. Dr. S.M. Dev. Good afternoon, sir.
Good afternoon.
Sir, Dr. S.M. Dev will be the chief guest of our validatory program, the speaker also of our 7th session. And Dr. Bishi Das is also here, probably. Dr. Bishi Das. Dr. Bishi Das. Dr. Das. Probably. And in our validatory program, our 2 special guests are here. Professor Sagar Sandal, sir. Sandal, sir, please unmute yourself, sir. Sandal, sir. Sandal, sir.
Yeah.
Sandal, sir. Yes, sir, unmute yourself, sir. Unmute yourself, sir. Probably some problem is coming. Okay, Professor Kannal sir is here, and Dr. Botopel is also here. They are the special guest of our validatory program. And our Dr. Sajian is here. He is also the speaker of the second session. So after the listening of the first session of our Madan sir, he will deliver his lecture in the second session. Dr. Sajian, good afternoon. So now we will start our first session, and but we are actually running 30 minutes late. So I am requesting to all the participants to bear with us. Our total today's program maybe continue up to 4:30. So please bear with us. Now there is one announcement before starting the program, that there is a chat box where the
Good afternoon, everybody.
yes, sir, yes, sir. The participants are requested to write their questions in the chat box, and our rapporteur will ask the questions for the discussion from selecting from the chat box within the stipulated time of discussion. And in each session, 30 minutes discussion time, and the rest period will be discussion. And there is one link will be provided at the end of the session, and you can submit the feedback within our before the closing of the program, or you may copy the link and send it within 10 p.m. of today. Now, I am requesting Dr. P.R. Ghosh, Dr. Prabal Ghosh, and Dr. Omlan Patho, Assistant Professor of our Animal Nutrition Department, to act as the rapporteur of these 2 sessions. Now, we will start our first session. Our speaker is Professor M.L. Madan sir. Already all of you know his personality, but he has some extraordinary personality. He is a man of something versatility in his nature. So I want to introduce the academic aspects of Professor Motilal Madan sir. Professor Motilal Madan sir contributed significantly in the area of national agricultural development across India in different agri-eco regions of the country, and particularly in the state of Haryana, where he was a member of the Farmers Commission. He specializes in the area of reproduction, animal improvement, environment, and biotechnology. His research innovated several protocols, for animal production and health. He pioneered research in biotechnology and IVF, producing 10 embryo transfer calves from a single elite female in 1 year, and world first buffalo IVF calf, Prothom, which greatly impacted research and development in the country. He successfully initiated embryo cloning work among buffalo in the country, which has culminated into birth of several cloned animals in India. Professor Madan has published over 226 original research papers in international and national referred journals with 417 total publications. He is fellow of 6 science academics, including National Academy of Sciences, National Academy of Agricultural Science, and National Academy of Veterinary Science. Professor Madan is a celebrated personality and is the recipient of highest national and international recognition and honors, including ICAR Rafi Ahmed Kidwai Award and Horiom Award, Om Prakash Bhashin Award for Science and Technology, Dr. B.P. Paul Award, highest recognition from National Academy, P. Sundarsan Award in Dairy Science, Nirmalan Award, Japanese Oguri Award, AGS Purnia Award, Sati Honorific Award, Distinguished Veterinarian Award Diva, ICMR Centenary Award, Manchananda Oration Award from Federation of Physiological Society FPS, Sene Oration Award from ISAR, Alumni Excellence Award from NDRI, Ramashami Oration and Lifetime Achievement Award from Indian Society of Reproduction and Fertility. Professor Madan has contributed significantly to national agriculture, veterinary, animal science, research, education, and development as chairman and member of several committees of ICAR, Science and Technology and DBT of Government of India, State Farmers Commission, Planning Boards of Universities, Planning Commission, Animal Biotech Task Force, Parliamentary Committee for Agricultural Education, Education Committee of Veterinary Council of India, and in formulation, evaluation, and monitoring of the research in ICAR. He is committed environmentalist and a mountaineer, champion cricket and badminton player, and devoted to art of poetry and music. With this word, I request our versatile leader, Professor Madan sir, to deliver his speech on challenges in climate-smart livestock production in India. Sir, please start your lecture.
I wonder whether the presentation is on the screen.
It's fine.
And it's audible, voice is, sound is okay.
Everything is okay.
So there is no better way of starting it than to thank you, Dr. Das, for this elaborate introduction, which in fact is an introduction not to me, but to the score of workers who have been with me all the time and who have been working with me, for me, and in me all these years. And it's their enthusiasm which keeps me sustained. And I'm glad to be associated with some of them even now in the pursuit of some passions which you said are with me and drive me. Friends, as you are aware, that this seminar is about the climate smart livestock production in India. There is an epitaph to it, and it talks about challenges. In fact, when we talk of, we have to be in the right perspective to be talking about the livestock in this changing climate. And it is there where the challenges are. And these challenges are, in fact, the drivers, the consequences, and the responses to climate. And therefore, I will be concentrating over onto those areas and bring about the perspective of this group of animals which you see in front of you on the screen. Now, these animals have evolved. And in the process of evolution, they have gained something and they have lost something. And this is exactly what the climate is doing. Now, is that a situation in which that we have to orient ourselves in a manner in which we are able to identify firstly, the definition which we have been given today, and that's about this smart production, smart climate. The smart climate in itself is the innovation to forecast and mitigate impacts. That's what we call as smart. And very fortunately, that the subject with which we are dealing today has got only one pathway, and that is the physiological system approach. Because what really we are referring to is that our body systems have to function in a response to a stimuli, and therefore we find that alterations taking place in the functioning of this system. And therefore, our approach should be the physiological approach in understanding how we can talk of a smart climate, smart animal. So the mitigation strategies for mitigation of the impacts of any climate through understanding of the effects of livestock on climate and the effects of climate on livestock, because these are two corollaries which we must understand. In fact, when we talk of smart climate, smart livestock production, the question mark comes is because we have data, we have got scattered data on the observations, and those observations are mostly on a macro level, that this happens to the group of animals, this happens to this breed, we have lost the potentiality of this breed. The whole animal track in the Rajasthan, for instance, is having productivity which we associate with the agro-eco conditions of that region. And these are all micro observations. But when we talk to have smartness in livestock, in climate livestock understanding, we have to have at the micro ecosystems which are more direct, and for that the studies have been very few. In the absence of location-specific scientific data, unclear understanding of the vulnerability to accumulate changes in adaptation and mitigation effort at local level are less effective. So in fact, what we have to do is that we have to design effective adaptation and mitigation strategies which will be assessing the vulnerability, understanding the community's coping mechanisms, and reviewing the existing policies, which become very important for constraining our smart agriculture. So, what are the implications? The implications are that we have to have a synergy of improved livestock breeding and feeding options and have an ex-ante analysis done. I hope you understand the ex-ante analysis. It is this ex-ante analysis which takes us back to what we had and how we have improved on that. We are also now talking of the technology applications, as a large number of assisted reproductive technologies are available. Technologies with respect to nutrition are available. Technologies with respect to the application of the various type of minerals and their use by the animals are available. So we have to talk of these technology applications, the breeding technologies which you have got. So combination of livestock and economic simulation models have to be done. Because when we are saying that we might not at this particular stage have the micro data as such, but if we are going for a simulation models, we'll be able to go what we talk of in longitudinal studies, by which we can have an understanding of the income and food security gains for households with local animals, and therefore have the economic and the environmental gains through breeds and through breeding strategies. And that's where the increase in income will take place and the adaptation mechanisms will be effective. So in fact, that when we talk of climate smart livestock, what we strive for is, number one, increasing livestock productivity. And through that, we are talking of the food and the nutritional security. Because it's this country we are today talking a lot about food security, but we are away from nutritional security. And whatever little nutritional security is there is because of the contributions which come from the livestock in terms of the milk from the nursing mothers and the newborn babies, as well as to the meat available, the protein available, and the acute protein deficiency, which our whole population, human population, is having. So nutritional security, that is one goal which comes out of this climate sensitive livestock production. The second thing is building resilience for agricultural systems in climate impacts. That is what we refer as adaptations. And we are talking now of getting over into the where systems will be adapted. And thirdly, we talk of what are the toxic things which come onto us, the mitigation of the greenhouse gases which are emitted as a process of livestock production. In terms of the physiology of the climate smart livestock production, the first thing will be understand the impact of climatic change on livestock, then the physiological innovations to forecast these impacts, and finally, that is the critical thing, the capacity building strategies for sustained livestock production. And it is here that please understand capacity building. What really we are referring to that smart livestock production means that in fact that we have to build capacity. And this capacity building is a physiological process. And therefore all our attentions have to go towards developing the physiology of an animal. And this has to be developed at various stages in various processes. For example, we have to talk of the functional relations between animal performance and the weather parameters. Now, once that functional relationship is worked out, so we are talking of probable knowledge and weather parameters combinations, because that will only be in giving a probabilities. But from them, we have to reduce a reduction to prediction of animal performance under natural conditions. So to do that, we have to expand ourselves, not into what we call as the vertical studies or standing studies as we have. We have a group of animals, we put them under test. These animals are with us for a year or 2 years, and we interpret them in terms of the responses. In fact, that is not climatology's response measuring. We have to talk of longitudinal profiling studies at body, that is the whole body, then the system, if we are talking of renal system, if we are talking of endocrine system, if we are talking of digestive system, then go over onto the organ. If we are talking organ, we have to go to the kidney, we have to go to the stomach, and we are talking then subsequently, once we go from into the renal, what's happening over in the kidneys, what's happening over in the exchange which is taking place in the rumen wall, or what is happening to the volatile fatty acids which are being produced in the rumen, how they pass out from the rumen to the reticulum, what is the uptake which is taking place even in the intestines, and what are the various types of immunophysiological changes which are taking place in the intestines, which will go over to the molecular level. So observation data analysis should reveal the insights into what? Insights into what is the protein coding genes and gene regulating mechanisms that influence capacities for adapting to acute and long-term increases, for example, in temperature, and how much change in sequence is needed to adapt proteins to warmer temperatures, and determining in terms of what are the alterations which we should be looking after or into them. So that is how we understand the climate change effects. And in fact, that when we talk of the climatic change, as I said earlier briefly, what we are talking of an evolution. Now, evolution does not stay for anyone. For that matter, it won't stay even for temperature change. Temperature change has been taking place over years. Not only temperature change, we have known of an animal which was as huge as a house, three-storied house building these days, with huge wings. We don't see that animal today. Now, where has this animal gone? Is that the climate affected the animal and then the animal changed? Or it is what we call as the true evolutionary changes which are occurring, and come what may, in spite of our all efforts, that we have to keep an eye that the evolution has its role and play. If we talk even in the total biome, that means what is the biomass in the country, it is very interesting because after all that it is the biomass conversions which is taking place on the surface of the earth, in this planet earth, that what we see is the transformation of energy which is coming from the sun and going into the sink, and in the process it is transforming the life. And this biomass, when we talk of these biomass considerations, that plants on the surface of the earth, on the global biomass, constitute about 82% of this biomass. Why I have brought it this plants 82% of the mass? Because I want to go to the next biomass, major important, and it is not the animals or the man. The next important biomass or the animal kingdom or the tiny bacteria, which constitute about 13%. And the animal kingdom, total animal kingdom, constitutes only about 0.4%. Now that's really small. And human account for just 0.01% of the biomass, which is insignificant. But we have played a major role in shifting the balance of animal life. Livestock, which account for only 4% of the animal biomass, but livestock for more biomass than the humans on Earth. And it is here where the criticality of the livestock comes, and that's how the fingers start getting raised, that it is the livestock that which is responsible for all the ills, if not all, at least major of the ills which we find with respect to the environment today. And it is in here that we have to sharpen our skills to find that how we should be able to tackle this issue. The picture, which is from the United Nations, gives us that by about 2080, you can see the picture very distinctly that there are areas in here, for instance, that we see that where we will have about the red areas, we will have almost about 25% by the end of the century. We will have about 25% decrease in the agricultural productivity. Now, please see this red color and see all these areas which are in the red color are the ones which are at present classified as arid places. Whether it is the Western Australia, it is Arizona, or it is the Mexico over in here. So all these things which we consider. So therefore, that at present, what is the type of this agroecology in these areas? We are looking for that those agroecologies is going to be changed, and we will have lower production from these areas where we will have lesser rainfall and more hot conditions. But these lower rainfall and better conditions will have an advantage. Will have advantage for those areas which are very cold now and will become warmer and will have a comparative advantage. So this is what we call changing agricultural productivity, and along with it, it is also the change in livestock productivity in the same fashion in the same areas. Now, if we talk the anticipated rise in temperature, which is supposed to be about 2.3 to 4.8 degrees in increased precipitation. Climate change likely to aggravate heat stress in dairy animals. Cold regions will have an advantage, as I said. There is devastation for low-income rural areas, especially in hot humid regions. Negative impact on Indian agriculture would also adversely affect feed and fodder shortages, which in fact will affects the animals quite considerably. And large source of methane emission and greenhouse gases through emission rate per animal, though is much lower in India than in other countries, in the animals from other countries. But unfortunately, we have a very large livestock population, which makes the emissions about 9 to 10 grams from enteric fermentation and from animal wastes. Therefore, we'll have a deeper look into the number one, the population structures. Then we talk of the food equations, which we have got, and then go over to innovation techniques and technologies with which we have to deal with respect to our climate change. I would firstly like to introduce you to this land mass. This land mass of India has got a carrying capacity. And this carrying capacity has to be understood when we are talking this huge population. We are talking about 1,320 million human population, about 535 million and about 851 million birds. Now you can see that they are all competing for the same land mass. And therefore, this land mass becomes vulnerable, greatly vulnerable to climatic change effects. And it is therefore the demography and the population. And demography is very important. Earlier, we used to talk of demography in human populations, but demography in animal populations become very critical these days. When we see that we're having a large group, lakhs of animals now, and an age group in which that they are not productive at all, but are still using the carrying capacity of this land. And therefore, our land mass becomes much more vulnerable and the climatic change much more vigorous. The effect of climatic change becomes geo-ecological fragility and socio-economic conditions. The population size, the density, the demography brings in a significant driver of climate effects vulnerability. And so therefore, when we talk of smart climate, we in fact are talking of physiology-based livestock practices, which will address simultaneously to the productivity in today's climate, build resilience to climate change, and reduce greenhouse gas emissions. The climate smart physiology includes not only proven practical techniques, especially in water, feed, reproduction, health, livestock management, and also ecosystem-based approaches, but also innovative practices such as better weather forecasting, early warning systems, risk insurance, monitoring of physiological parameters, and having accordingly approaches made in order to handle the animal populations. The first and the foremost is to understand how this climate itself is producing its effect on animals. Earlier on, it used to be what we call as a colloquial approach, that we'll keep an animal somewhere and we'll find out what's happening to the animal. But it is that pioneering work in the laboratory, a Broaday's climatic chamber, the only chamber of its kind in the world, that where you could put a single animal in a room and subject it to all types of climatic alterations. I say climatic because when I say climatic, I'm talking of environment in here, that you could bring about an environmental change. And environment was not only single temperature or humidity, but it was a combination of all parameters which make the climate today. And it is in this laboratory that physiological evaluation, for the first time started. And Professor Brody, then Johnson, and then his group, and made a series of experiments. And lately, Leroy Horn made a series of experiments to show that how this effect produces. I'm just giving you a graphic account of some of the research work which we did were in the laboratory in itself, to show very convincingly that how, as a single parameter, heat stress shows. And here you can see very distinctly that in heat stress, we can see that when the feed intake, it is under thermoneutral conditions, it is under hot conditions, that you find that the feed intake lowers. You can see over in here, the rectal temperature increases. here and here. And then we have got the criticality. For the first time in the world, we showed that how the hormone, the micro quantities of hormone are affected, that we have got this LH peak, that it gets affected because of heat stress. And that's how we find alterations are brought about. And this led also us to experiment on several other hormones, showing that how that the micro level within the body, that means at the molecular levels, that effects are being produced in terms of the stress which an animal is undergoing. Now in here shows that what is this type of heat stress? If we take the whole century, we take the full last century, you can see that how the temperature has changed over in the last century, that we're having a temperature shift of about almost 1 degree Celsius over in the year's time. Now this shift was taking place. Now the rate of this shift is getting mastered much higher and harder, because we are talking today that the man and the animal together are now making things difficult as far as the climate is concerned. And that's how the stressing is more. And you see that we are talking now that by the end of the century, there will be about 4.8 estimated increase in temperatures. And this will throw out the whole lands, the water masses will have more water, we'll have islands getting under the water, we'll have impacts of livestock, including changes in production and quality of feed, crop, and forages, water availability, diseases, reproduction, biodiversity. And these impacts are primarily due to increase in temperature and atmospheric carbon dioxide, precipitation variation, and combination of several factors which are accompanying this climate change. If we want to summarize, without going into the long details of that, what really happens under this, any environmental stress, intensity of the environmental stress, duration, and given the animal the amount of stress which it takes, that there are responses which are being produced at the animal. And these responses will be in behavior, these will be in terms of animal immunity, this will be normal physiology, and these will get disruption. We will have a disrupted behavior, we'll have impaired immunity, we'll have impaired physiology, and then an impaired function. And as long as this stressor, which is it is in a threshold level, we'll have the conditioning, or we'll have an adaptation which is taking place, and this adaptation will go back and therefore will give better resilience or better capacity of the animal to withstand the situations. But that doesn't always happen. This thermal environment, it can bring about considerable shifts over into, for example, the shifts in the acid-base balance, heat stress, animal health problems will come out, compromised productivity will have, and ultimately it will result in reduced production. And it will also affect the protein and fat accretion in the animal production, that is in the meat, milk, and eggs. Here is the thing, a physiological capacitation, which has recently been put forth in print, where we are talking of now biomechanical changes which are taking place as a result of climate alterations. And these biomechanical changes are at the cell level, tissue level, then at the organism level, and it bring about the changes in the fitness. And it is here that where we need to understand that how the climate smart animals are also produced. Now I will talk of these animals develop strategies for thermoregulation. They have got strategies for transformative action of climate change. And if I want to find out, if you want to picturize in front of you, look to a desert rat. This desert rat lives in desert. How does it live in a desert without water? It produces no urine to itself. It uses its own body to produce water, and therefore that this survives. We have got these cold and hot camels and how they sustain themselves, how their altered physiology is. We have got the reindeer and the caribou. They stand at the temperature of minus 43 degrees Celsius. They're all range animals. But their body temperature is 38 degrees, core body temperature is 38, but their toe temperature in the legs will be something like about minus 24 to minus 34, when the outside temperature is minus 42. And there is what we call as recurrent functional exchange taking place. And that is the type of adaptation which has come over in this. And this is what we call as the smartness which these animals have achieved. Similarly, smartness in an Arctic fox, a smartness in our native Indian animals, in our native crossbred animals, by which they are able to produce now quantities of milk as much as 13 liters, 14 liters, and our crossbred animals as much as 60 liters of milk under very hot, humid conditions. And this is what we talk of the resilience which they have got. They have developed a smartness which we need to understand today. And therefore, these behavioral strategies, the environmental drivers, affect the functions, neural control, and thereby the movement of the animals. And they can, over a period of time, bring about that type of adaptation, and which is a positive thing about. So we should not, at any moment of time, think that the climate itself is all disastrous. But if we tap this, if we manage it, I hope that we'll be able to do it in a better job on that. I will like here to say two things about these animals that which adapt themselves and are able to produce because they make alterations over into their metabolism and their functionality of organs. And that's how that we see that these functionality of organs and this functionality get subsequently transmitted from the what we call as the non-expressive gene regions to the expressive gene regions, and finally transmitted to the genetic code. Not only that, this climate also affects a host of livestock diseases because it is involved. It brings about a high temperature and greater humidity, increases pathogens, the vectors, the anthropanoid vectors. Some livestock will be exposed to new pathogens and vectors. There is a climatic stress, heat, inadequate food and water will lower the immunity. Ecosystem structure and function will change, and human behavior will also bring about changes which may affect its how to keep animals, how to deal with animals, and how to affect the exposure and vulnerability of animals to pathogens and vectors. On one hand, I was talking that how there is an impact of climate on animals. And on the other hand, we have also to understand that animals also impact on the climate, which is also much greater and much deeper. And that is how the reverse situation is coming out through the increased gases, for example, nitrous oxide, through the increase in carbon dioxide and increase in methane. Animals are supposed to be contributing to the climate change, which in fact will be then impinging on the animals themselves. I want to portray before you just quickly that this green areas in this bar diagram, which these are says that the green area is manure, the gases which come out of the manure over in here. And similarly, that when we talk of the pigs, indirect, and we state in here that among the pigs, manure management, that the pigs, the manure management of the pigs, that's where they are major contributors to the gases, to the CNGH emissions. I did not get into these things, but details of it, but it is suffice to understand that whether it is cattle, it's buffalo, the small ruminants, pigs or chicken, they all are to a various amounts of degree contributing to the greenhouse gases. But the degree which they is variable, and we have much leverage here in this country in terms of that. So we have, therefore, in terms of climatic change, two things. Firstly, a continuous increase in temperature is predicted, and secondly, the livestock production is to limit the release of greenhouse gases. Now, if we take the two together, then we have to talk of implementing new and adapting climate-smart production systems. And they will be, the first thing will be that we should have the feed available to the animals, and that's where we are talking of forage-based climate-smart livestock production. Major implications for improving food security, alleviating poverty, restoring degraded grades, and mitigating climate change is that we should have improved smallholder farming systems and break the cycle of poverty and resource degradation. We should also have a better distribution and our availability of rainwater to our agricultural operations and for our animals. In spite of the fact that we might be having a rainfall of about 400 to 600 millimeters, but unfortunately, if this rainfall is not equally distributed, that the productivity, agricultural productivity gets affected, and the animals also suffer for want of good water. Biological changes, including the change of flowering, the harvest seasons, changes in quality of pests cause population changes and the biodiversity patterns alteration. So there is the functional relationship between animal performance and weather parameters, and it is this relationship which combined with probabilistic knowledge and weather parameters permit prediction of the reduction of animal performance under natural conditions. Carbon sequestration is a major problem with respect to the agriculture, but it also comes up because when we talk of soil organic carbon, which can be restored from cultivated soil for conservation, tillage, erosion reduction, soil acidity management, double cropping, crop rotations, and high crop residues, and mulching, and more. I think, therefore, that towards the end, I would like to say that it is the holistic approach to livestock production which should be in terms of climate smart. And here we have to identification of the climate smart physiological capacity building parameters. So the first thing will be to develop these parameters and implement them by incorporating in the management practices, which will include, for example, the agroforestry for arid and rain-fed areas, grazing land management and pasture improvement practices, integrating crop livestock management. And that's where we have to see, and there should be an holistic and integrated approach, that whenever we are talking of withstanding the climatic effects, it's not that an animal has to stand, we have to talk of total agriculture. We have to talk of feed and fodder management practices, the nutrient supplementation, housing, shelter, and water management. By just providing better shelter management, we have seen that the animal do not suffer the stress in the same fashion as they would if there are no such shelters. Agriculture crop management practices in mixed farming, that's animal as well as crops. Adaptation of adapted temperatures, drought-resistant species and breeds, improved processing, packaging, storage, and marketing techniques, and livestock manure and wastage management practices. And last but not the least, the proper livelihood management. It is here that when we say that even if that species is given to a particular area, for example, Garol was there in Sundarbans. We have taken them into Rajasthan. We have seen that the Garols are now performing. And as a matter of fact, that the Avishan sheep, which has been produced through Garol, through genetic selections, are now giving us about 3 to 4 kids at each lambing. And this is putting that gene which Garol had over into our sheep, over into this completely desert area. So this is the type of activity which we need to go. Friends, I need to bring about one important aspect. That is, we talk of climate smart agricultural livestock production management. I have before you 2 charts, and please look into them very carefully. That's what I want to talk of, this Punjab agriculture in post-Green Revolution era, some perceptions and reality checks. That today, we are talking that in Punjab, we are having the highest milk production. Now, what is this milk production coming from? If you look the top curve over in here in this graph, productivity trends. It's not the production. This is the productivity trends I'm talking of. And in productivity trends, you can see the milk production over the years. This is from 77 to 98 to through over to 2018. We are having that the crossbred production has tremendously increased. This is the productivity trends. While we talk of the buffaloes, we see that 6.13 to about 8. And when we found up this is the highly selected Indian saiwals that who were about 2.83, and they have come to about 6.91. Now, what I want to say in here, that look at this group of animals. These are what we call as the crossbred zebus. And these crossbreds now are having an exotic blood of even up to 98, 97, 96%. And they are performing, giving as much as 60 liters of milk a day under their local management. So what is we are talking therefore of? That climate is going to eat away our animals away. If climate is there, if the management is along with that, we find that such a situation does not arise. Similarly, I give in this graph, which is on the left side, that the profitability from a crossbred cow and from a buffalo, this is from the research which has been done at Punjab Agricultural University. And this is the latest activity in which I am involved in and trying to find out this. This is the this I got only a couple of days back, this information, with respect to the net income per year per animal. When we talk of buffalo, about 15, we talk of crossbred cub, about 13. And so what is the signal? Signal is very important. As Dr. Dillon in his publication, the latest publication, has said, widely held perception about Punjab agriculture are a myth that productivity is stagnating, soil health is deteriorating, indiscriminate input use is increasing, pesticides residue level is rising, and agricultural, that it is declining, production is declining. As a matter of fact, all this is not happening. I have data which has given to me, and he has sent it to the publication. The publication is with Current Science, that where it has been shown that in all respects, the agriculture is doing better under these climate change conditions, even which we have today. And interesting thing is that year over year, we are having increase in production. Whether it is meat, whether it is eggs, it's milk, there is increase in production. So therefore, it means that the animal's resilience and this is there. We have only to play a proactive role in ensuring that we are providing the right type of a climate to the animal to express itself and allow its genes to express. And therefore, my conclusion will be understanding the basic physiology behind the climatic change-induced production loss or gain, adaptation mitigation practices. We are talking of diversification of livestock animal within species using different crop feed varieties and shifting to mixed crop livestock reforms. Tolerance to climate variability, drought, heat waves, and to diseases. On the mitigation side, improvement of animal nutrition and genetics are important because enteric fermentation is a major gas emitter in livestock production. Our more research is needed over in there. If we want effective adaptation and mitigation measures to address climatic change and livestock production, these measures should be scaled up through policy framework. So what's important is that along with that, all the work which we are trying to do in terms of producing a smart animal to take up the challenges of climate change, we must also have a simultaneous policy framework going on and a comprehensive view of costs, time, and effort required from the producer's need, since it includes that we need an source for sustainable production system. Finally, what's the message? Message is that there is research evidence showing decline in animal performance, inflicting heavy economic losses when subjected to climate stress and change. But the qualification I have already said. With the development of molecular biotechnologies, new opportunities available to characterize gene expressions and identify key cellular responses to changed climate factors. These tools will enable improved accuracy and efficiency of selection for heat tolerance and performance. Systemic information is generated on the impact assessment of climate change on livestock production may prove very valuable in developing what we call a smart, appropriate adaptation and mitigation strategies to sustain livestock production. Friends, there is definitely lack of information related to the current use of adaptation and mitigation measures. But it should be our endeavor that we go over into it. And because of the breeds and species are not a renewable source, it is important to identify these breeds with inherent genetic capabilities to adapt to this climatic change. And also that there is a gap in knowledge related to the nutritional and metabolic processes of livestock. Addressing this can improve the management practices that increase animal performance. Thanks, gentlemen. I hope you have enjoyed, and I have at least enjoyed speaking in this web seminar, and will be glad to be interacting with you on the mail address which is given in here or in person communication. Great pleasure, and thanks to DAS and the West Bengal University of Animal and Veterinary Sciences and Fisheries to have given this opportunity to be speaking to you and presenting these some thoughts, raw thoughts. I need not to be very vehement in either direction, but I just wanted to bring about that we should not get overbogged down by saying that climate is going to bring us down. We have innovation, we have ingenuity, and we shall be able to face this ingenuity the way we have at present facing the greatest calamity which has ever happened to the mankind, and that is the COVID-19. Let's take lessons that we have the resilience and the capacity to face it, and climate will be no different, and we'll be able to take this challenge. Thank you very much.
Thank you, sir. Thank you for your nice presentation. Sir, actually, you have tuned the spirit of our workshop. So our participants are very much excited by seeing your presentation, and you have very clearly demonstrated the impact of the climate in the animal production, and particularly the effect of the green revolution, which you have explained at the end part of your discussion, is very much helpful for the main spirit of the discussion of the workshop. So again, we are giving thanks to our organizer, to President Madan sir, for his nice deliberation. Now we have very constraints in times. However, I am requesting Dr. Ghosh, if you have some questions, please you can place 1 or 2 questions maximum to complete the session within a stipulated period of time. Dr. Ghosh, please, if you have the question, can please be here. Please here.
Thank you, sir. Actually, there are a lot of questions have come both in the YouTube channel as well in the Google platform, and all are excellent. But due to paucity of time, already we are running late, about 20 minutes late, I think. So I'm just asking 2 questions to sir. First question is that animal production systems are required to be intense due to fulfilling the demands of our increasing human population, which further intensity greenhouse gas emission problem. Therefore, which is more concerned, increasing human population versus increasing greenhouse gas? Sir, could you hear?
Yeah, I believe that it's not either, it's both.
Oh.
As I said very clearly, that it is the human population which is impinging on the carrying capacity. And then we have got, if we have got greater human population, the human population demands that we should have greater amount of animal products. And therefore, we need to have greater amount of animal production processes, greater amount of animal being utilized for producing animal products, and therefore that one is leading into another. That's what it is, the vicious circle. But what I said earlier, that is to be taken into the picture, that we have to have an eco-friendly, an agroecological friendly production systems, in which that we see that our emissions are minimum. As a matter of fact, that India, I am sure that you will be hearing more from my trusted colleagues. Dr. Kamra has done considerably good on this issue. That as far as this greenhouse gases is concerned, that we are very low at it. The only thing is that if we are able to channelize our systems better, if we are able to give a better supplementation to the feed, and through these better supplementations reduce the gases, I believe that that this is not a major issue, that compared between the human population or the emissions which are coming from the livestock. The major issue today is the numbers, whether it is the human numbers or it is the animal numbers, and we have to tackle that as a critical issue.
Thank you, sir. Now, I am putting another question to you, sir. Sir, as per the Darwinian theory, could you hear me? Hello?
Pardon?
Could you hear me, sir?
Yes, yes.
As per Darwinian theory, animals and humans will get adapted with the changing climate. So, it is a natural adaptation process. Why should we get much worried about climate change and its relation of animal production?
I said it very clearly. I think that is one of the messages I said, that we need not to get too much alarmed, because in the fact that the human being has to change. The man which is man as it is today will not be the same after about 60 years. And we see that such type of changes are already occurring. And therefore, there is a continuous evolutionary processes. You see, how did man start? Man started by, it was no other different than an animal in the jungle, as the when man started. But over years, I think this is interesting. Over years, what happened? That the muscle power which the gorillas at that time had got converted into the power in their, that energy, it got diverted into the brain. So we have about 60 to 80% increase in the brain size. But what will in the process lost the muscles and the skeleton. So today we are not having gorillas, but we are having human brains. And tomorrow, as you see, that the more and more robotics are coming up, more and more activity is taking place. Similarly, our activities and affiliations will also change accordingly. I'm sure that you for yourself see what are the likes and dislikes of children who are born today, and how that is distinctly different from the generation earlier. And therefore, for them, for example, a comfort is different than the comfort which used to be us. And a khatia under a tree used to be a comfort for us. But for them, that's an absolute discomfort. So these things are which are coming as an that question for our climate adaptability. But the thing is that simultaneously the man keeps up evolving himself, and so the climate will evolve itself, man will evolve itself, and then the process of evolution will keep on happening. But this evolutionary changes may take sometimes hundreds of years, and therefore is not that sometimes which is going to impinge on me directly now. What will impinge on me is, for example, the availability, feed availability, food availability, comfort availability. And to that, we need to take the measures of which I have been discussing to you and I have outlined.
Thank you, sir. Thank you, sir, for your excellent thing. So now I am asking Dr. Pradeep Das.
I will appreciate the type of questions which are being put. You can forward them to me, if possible, for me, and if I'm capable of doing it, I shall be replying to them by mail.
Okay, thank you, sir.
So you can forward them to me.
Yes.
Okay, thank you, sir.
Thank you, sir. I am also requesting the participants, so please bear with us, because we have very less time in our hand. Already we are running late, around 30 minutes or more. So I am again thanks to our Madan sir.
Dr. Kamra has a question.
Yes, sir.
I just wanted to add something. I don't have any question because you have very nicely explained everything, that there is no need of asking question. But I agree with you that because of the low producing and non-producing animals, our statistics goes towards adverse conditions, that we are producing more methane as compared to the developed world. Is there any way that we can reduce the number of non-producing or low-producing animals? Because you have been in member in many committees constituted by Government of India. I wish that it can be a very good thing that if you raise this question uh, in those meetings. What do you think?
Well, I think that I will discuss this with you individually. But let me talk one small thing here, and that is that you see we have to look into that our increasing population is putting up tremendous strain in terms of our demand. You see, today we are increasing at about 4.5% of milk production. But if by 2030 we need to still look to the population demands, we have to increase to a degree of about 6 to 8%. Now, 6 to 8% increase in milk production cannot come by putting in 1.5 kgs or 2 kgs of milk into our mundane animals, to our nondescript animals, and saying that we are talking of grading up. I'm sure Das is there, and also we have Dev, and they will be also listening to this. That we just cannot put in that thing and say that we'll be able to achieve that. But then we, at the same time, we are having this system in which that we are going, and there is a need for a policy change in there, which probably will come over in periods of time. Thank you.
Yes.
Okay, sir. Thank you, sir. Kamla, sir, also. Sir, Madan, sir, we are very much thankful to you for your nice deliberation and discussions. Sir, again, I think that so we are organizing committee. I am very much thankful to you for your nice presence and nice deliberation. We are very much enriched about your deliberation. Thank you, sir. Now we will start our second session. Before starting the second session, just one announcement. Dear participants, you will get the feedback form at the end of the session. You can fill in that form before the closing of the session, or you can copy the link and then send within 10 tonight. So now we will start our second session. Dr. Ghosh and Dr. Patro will act as the rapporteur of this session. Before starting this session, I just want to introduce our speaker, Dr. Virasamy Sajian. Dr. Virasamy Sajian, presently working as the senior scientist of the animal physiology at National Institute of Animal Nutrition and Physiology, Bangalore, India. Primarily involved in research pertaining to stress and climate change, impact and mitigation in small organisms. He was an alumni of our department during his master's. After doing his PhD in Indian Veterinary Research Institute, he completed his postdoc at the Ohio State University of USA. His notable work encompasses the concept of multiple stressors impacting livestock production under the changing climate scenario. He has published 139 peer-reviewed research articles in international and national journals, 87 book chapters, 256 lead and invited papers, and 23 technical manuals and training compendiums. He has also published 2 international Springer books entitled Climate Change Impact on Livestock, Adaptation and Mitigation, and Environmental Stress and Amyloneuration in Livestock Production. He is also serving as editorial board member in 20 international peer-reviewed journals and involved as chief editor-in-chief as for an international peer-reviewed journal named the Journal of Physiology and Pharmacology Advances. Dr. Sajian has been bestowed with many prestigious awards and fellowships from India and abroad, such as Lal Bahadur Shastri Outstanding Young Scientist Award of ICAR, Endeavour Research Fellowship at the University of Queensland from the Australia government, Ian Mollick Memorial Award from the Society of Animal Physiologists of India, Faculty Research Award 2018 by Careers 360. He also received many travel grants for international symposia, like Guest Travel Award for delivering keynote address at the International Symposia on the Nutrition of Herbivores, France, and grant from the International Brain Research Organization (IBRO) for 19th National Meeting of the British Neuroscience Association in Harrogate, North Yorkshire, UK. Now, I am requesting Dr. D. Sejian to deliver his valuable talk on climate change and small ruminant production, current scenario, and way forward. Dr. Sejian, please start. Dr. Sejian, please.
I'm here.
Yes.
Thank you very much, sir. At the outset, let me first thank Professor Madan, because he has been a role model for all of us being a physiologist in India. It's been a proud moment for me to share the platform with him to talk about it, because it's like a dream come true for a physiologist. So that is what today the feeling and the emotions are, that the way he has narrated his lecture and the way he has explained how fantastic the basic concepts of the physiology, and we all grown inspired by him. And today it is a dream come true for me for being able to present this talk before him. Thank you, Das sir, for the nice introduction. And I also, without forgetting, must mention that today what I am for a physiology, I owe a lot to Professor Sagar Sanyal, who was my major advisor and ably supported by Professor Das and Professor Ghosh for as advisory committee members, because they are the one who taught me what is goat and what is research in goat. My research activity have started from the West Bengal. It's always my second home. I always call it. Today, what I am, where I am standing, it is by these three personals who have made an immense role in my professional career. So with this few introductory remarks, let me start my presentation. The topic given to me today was climate change and small ruminant production, current scenario and way forward. Professor Madan had more or less given a broader picture of predominantly the cattle, because he is basically from NDRI, so he has given, and with his vast, rich experiences, he has explained detail. I will be pertaining to the small ruminant, my talk would be oriented. This is what we talk: climate change and small ruminant production, current scenario and way forward. And this is going to be my plan of talk: climate system and global climate change and its consequences. I will talk a little bit about heat stress impact on the small ruminant production and what is that nutrition and walking stress in small ruminant. And I will be talking specifically about the concept of multiple stresses by me and my team who have identified this concept, and advances in the various advances that are present now before us for assessing the thermotolerance of small ruminants, and what are the different agro ecological zone specific goat breeds that are available before us, and then what is that identification of advanced biological marker probably to use in the marker assisted selection, with some conclusion and future perspective. Well, audience, I always start my lecture by showing some pictorial representation of what we have witnessed in last 10 or 15 years or so. This is the tsunami in 2004. We have not forgotten that the entire coastal area of Tamil Nadu have been washed out. And you can see this is the Uttarakhand flood in 2013. You can see the pictorial representation of what impact it had. And then this is the Chennai flood in 2015. Again, you can see that devastating effect of the natural climate change, which is linked to. And then this is the Kerala flood in 2018. You can not very far away we are from this. You can know that the entire state of Kerala have been washed out. So these are the events that has happened thick and fast, and we need to understand why these events are happening pretty thick and fast in the last 1 decade or so. So this is very important point to be answered. And these are some of the facts about the climate change. Around 262 million people are found to be affected by the devastating effect of climate change since 2004. Quite alarmingly, 98% of such population comes from the developing part of the world. This is because we need to understand why it is so, why not the developed, why it is developing. It is because we don't have good preparatory system in place. Professor Madan had already told that we don't have good early warning systems that need to be developed. That is probably the reason for why the developing part of the world is the culprits here who are getting affected more. Around 30 million people are likely to go hunger as a result of climate change, particularly the agricultural yield reduction. So then also the World Health Organization promotes that around 150,000 people are dying every year as a result of the climate change. That's why the IPCC requested everyone to come and sign the climate bill, which has happened in 2016 in the Paris summit, where it has been every country have come into and then signed the climate bill. Well, this is an important data for us to understand, and you can know that I have programmed the average earth temperature from 1860 until 2100, and from 1860 until 2000, I have drawn a line to show where we demarcate the world from industrialized era with the pre-industrialized era. From 1860 until 2010, probably you can see that the average earth temperature varied somewhere between 13.5 and 14.5. The rectangle shows that, and you can see that this is because we have to differentiate here two terms. One is climate variability, and the other is the climate change. So, like you can see that naturally, by natural means, any year could be a warm year or a dry year, a wet year or a cold year, or it could be. So this could be explained for the reasons for these variations. But then what it is currently, this line draws here where we are in reality now, we cannot call this point and this point as a climate variability. There is something happening around particularly 2000, these events have congregated. What I have showed previously, some couple of devastating effects of the climate change that have congregated around 2010. That is because where the industrial revolution have taken place, and then they have contributed immensely for the carbon pool of the world. So that as a result, that these are the events that are taking place and animal gets affected. IPCC comes about with a projection every 5 years. And as per the latest fifth assessment report published in the year 2013, IPCC claims that by the end of this century, from the point of now, the range of around 2.6 to 4.8 degrees centigrade increase with a central estimate of around 3.7 degrees centigrade. Well, last 15 years or so, the rigorous experimental finding of mine says that even a 1 degree centigrade increase in the upper critical temperature is extremely detrimental for livestock production. One need to understand here, the adaptation means the animal should adapt and produce optimally. But what happens now is that predominantly what all the feed that is being consumed, the animal uses them for the adaptive mechanism. There where the problem arises, because it is not the question of adapting, it is adapting and producing optimally. So this increasing temperature, which is, there are several other bodies which projects that it is going to be much more than what the IPCC projects. Well, with a central estimate of around 3.7, almost sure of getting affected, we need to have good preparatory system in place to tackle the issue. In any concept in science, there will be always two school of thinking people. Like climate change also is not odd to that subject. Again, here also two school of thinking peoples are there. The first school of thinking people always believes that climate change is a natural phenomenon and we don't have much control over it. And it is natural, unavoidable, adaptable, and very slow. Whereas the second pathway where we are all, there is a survey done by the IPCC itself, and then they come about with a projection 98% of the world population believes that climate is changing. And they all belong to the second pathway where the human-made or the anthropogenic contribution, it is called as accelerated climate change. Abnormalities, very difficult to adapt and avoidable and quite rapid. That is why it is a pressing global issue currently, and we need to work on a multidisciplinary approach to tackle the issue. Well, this is a pictorial representation which shows the food security point of view. What is the vulnerability index? Because the above figure is that present scenario. What is the below is the future 2050 scenario. You can see that by 2050, the world population is expected to hit around 9.6 billion. Where is the resources to feed this growing human population, especially with the changing climate in place, and it is threatening our agricultural production yield? There are ways and means we need to tackle this issue. Well, you can see that most of the African countries and the Indian subcontinent have always been on a higher vulnerability index because of the growing human population and the animal population, particularly the small ruminants, are tipped to be playing a huge role in ensuring the food security with a rich animal protein. Well, coming to the impact of the climate change do not cause only the heat stress. It causes multiple environmental stresses where it could have a direct effect as well as it could have an indirect effect. The direct effect by all means the heat stress. In some part of the world, it is the rainfall or cold. And in by far, Indian scenario, if you say, the most of the productive losses are incurred as a result of the indirect effect, particularly the sudden disease outbreaks, the vector-borne diseases, and less feed and water availability, as well as the low grazing or pasture land shrinkages that are happening. These are the things which contributes to the reduction in production, and because we are predominantly having indigenous animal population, and they can quite counteract heat stress quite effectively. So therefore, the most of the productive losses should be understood that they are all contributed by the indirect pathway of climate change. Of course, both the pathway can culminate in affecting the livestock production, which can cause severe economic constraint for a country like India, where the major chunk of economy comes from the agriculture and allied sector, particularly livestock. So this is a serious consequences outcome. So, and this is the reproduction in a nutshell, how the heat stress impacts the sheep reproduction. Okay, it can have a two-way pathway. By any means, the animal, when it's subjected to the heat stress, they try to reduce their feed intake. So as a result, what happens is that it could cause a negative energy balance in the animal. Even the less amount of feed that is being consumed or deviated for life-sustaining activities such as respiratory and cutaneous evaporative cooling mechanisms. As a result, they can go and act on the hypothalamus and reduce the GnRH production. Whereas the heat stress also could directly act on the hypothalamus and then the control centers at the head, and then they can decrease the GnRH production from the hypothalamus, which in turn can act on the anterior pituitary and cause reduction in the production of FSH and LH, which could cause at the ovarian level decreased estradiol production with altered estrous cycle and altered sexual behavior, ultimately culminating in decreased oocyte quality, decreased embryo production, and low fertility. And obviously, it can cause the reduction in the milk production as a result of increasing in the temperature. Well, this is the meat production. Okay, you can understand that there are very limited reports currently in the world. We are happy to share that we are one of the group who are currently working on meat production in particular because of the small ruminants, because this is very important productive responses, particularly from the world point of view, from the food security point of view. The meat producing animal need to be produced more. So like you can see that the various consequences of the heat stress, particularly this concept you have published in Meat Science, which is highest impacted in this research area. And we can see that almost live weight, pre-slaughter weight, hard carcass weight, dressing percentage, loin eye muscle area, separable fat score all got reduced. Most of the organoleptic tests got reduced. Even the quality reflecting some of the important biological markers such as myostatin and HSP70 got down-regulated and up-regulated respectively. And there are other proximate composition and other primary cuts are all get reduced. We did this experiment in 3 breeds, and I have some results to show in the end. And this is how the animal try to adapt to the situation when they are subjected to adverse environmental condition. So what happens is that again a two-way mechanism like that of reproduction affection. Like that, you can see that the first pathway is again due to less feed intake, deprived nutrition, which could cause a negative energy balance, and ultimately it can act on the hypothalamus, which can stimulate the hypothalamus to release more corticotropin releasing hormone, and it can act on the anterior pituitary to produce ACTH, adrenocorticotropic hormone, which in turn can act on the adrenal gland and then produce more cortisol, which is the principal stress relieving glucocorticoid in the ruminant species. And then there are also the animal tries to adapt behaviorally, which is the first mechanism that comes into picture when they are subjected to adverse environmental condition. They could alter their standing behavior, their lying time increases, their drinking frequency increases, and they reduce both the defecation and urination frequency in an effort probably to store body water to prevent dehydration happening. They bring in such mechanisms. The animals are also the other set of variables by which the animal try to adapt is that they bring in the physiological mechanisms such as the respiration rate or the panting, and then the cutaneous evaporative mechanism through the increased skin temperature as well as the rectal temperature. Obviously, the aldosterone which is produced from the the adrenal cortex also can play a huge role in electrolyte balance. Obviously, from the liver, most of the culminating activity of cortisol is on the liver by bringing in the hepatic gluconeogenesis, that is conversion of non-carbohydrate sources into glucose, probably for supporting the life-sustaining activities such as respiratory evaporative cooling mechanism and cutaneous evaporative mechanism. To support this very vital life-sustaining process, we need continuous glucose supply. That is what the liver is doing by converting the non-carbohydrate sources into glucose. Obviously, in the liver, there are also heat shock protein, which is considered the ideal cellular marker for heat stress, gets overexpressed. This is the sequelae of event that takes place when the animals are subjected and how the animal try to adapt themselves. And you can see that it's a proud moment again with some of the world's stalwarts who are renowned climatologists relating to the animal production. We have associated this, and then we have presented this as a lead paper last year in the France. And this is again, I'm sure Professor Sagar Sanyal is watching all these things. He would be a proud teacher for me, because he must be very happy about the way I have progressed myself from where I left at Calcutta with him under his able guidance. And this is the publication from Food and Agricultural Organization, Feedipedia, where they recognize some group who are currently working. And in 2016, we have published this detailed impact of whatever I have discussed today can be downloadable here, impact of climate change on the livestock productivity. And this is the nutritional stress model we followed at Rajasthan previously when I was working as a scientist at Central Sheep and Wool Research Institute. We followed different methodology in the extremely summer condition. This is what the level up, that is 70% less than the feed that is have to be fed for the animal, only is the requirement they get during the grazing condition. And we got some very good publications emerging from that. This is in the sheep, this is in the goat, where at NINP this work was conducted again on the nutritional stress model. And this is the walking stress. And again, I'm happy to share here, we are first group to project the walking stress to be one of the another important environmental stresses, particularly from the extensive system point of rearing, where extensive system predominantly being practiced in the country. And this is the concept which is very vital to understand. This is another important environmental stress that affects the livestock production. And we are very happy to share that paper has been published in the International Journal of Biometeorology, effect of walking stress on the growth, physiological adaptability, and endocrine responses in Malpura ewes in a semi-arid tropical environment. So this is nothing bad. We kept the rest all the conditions neutral, and then we have used some indigenous face masks to prevent them from grazing, and the control animal will be kept in the shed, and they will also will be deprived of nutrition when these animals are set out for walking. We have measured by ourselves. They travel around 14 kilometers in the year in a day during the summer season, and then we stretch them 7 kilometers in the morning and 7 kilometers in the afternoon with an 1 hour break for the animal. And then we conducted the study, keeping only the difference between the group of control in the shed and the walking animal, the locomotory activity. And we identified through 80 odd variables that this is another important stress which could play a major role in reducing the production for this livestock species. And you can see that almost water stress, there are more research need to happen. Of course, this is an area where, and the disease occurrences relating to climate change and the water stresses relating to the climate change, very, very negligible reports in Indian scenario is available. These all, you can see that almost the barren land, where is the animal during the grazing condition, where is the water for this animal to consume, and that could have a serious impact on their productive ability as well as the adaptation as well. And you can see that I have discussed about the heat stress, nutritional stress, which could be feed and water, as well as the walking stress. All these three, if you can see, as a layman understanding, I can ask a question to the audience that these stresses do not happen individually. In a summer season, for example, there will be heat stress. There will be less feed available for the grazing animal, and there will be less water available for the grazing animal. Of course, the animal also should have to walk a long distances, because it is predominantly extensive system of rearing. They have to walk a long distance in search of this limited pasture. So if you can see that all these stresses are happening together. So if you target only the heat stress, I think the purpose may not be serving particularly, because these are the cumulative stress that need to be addressed. And I'm happy to share with the audience that we have developed, under the leadership of Dr. S.M. Naqvi from Central Sheep and Wool Research Institute, we developed this concept of multiple stresses. I'm happy that the Indian Council of Agriculture Research have recognized me for developing this concept and bestowed me with the Lal Bahadur Shastri Outstanding Young Scientist Award. You can see that I have just a hypothetical model. I will try to explain that. You can see the first part of the picture can say that thermoneutral condition wherein animal animals are blessed with some sort of body reserve, and these are all the productive function: growth, reproduction, milk, meat, and immunity. And the basal functions are very vital for animal survival. What happens? Usually, we think that the heat stress, for example, you can take the second picture, when the animals are subjected to, particularly the indigenous animals I speak about here, when the animals are subjected to single stress, what happens? The animal can counter that stress without any much compromising on the production with the help of a body reserve, what it was present in the previous picture. Whereas when they are subjected to 2 or more stresses, this body reserve is not sufficient. Ultimately, animal have to compromise one of its productive function in an effort to cope up, because animal can compromise the production but not the adaptation, because adaptation is very vital for survival. So these basal function have to be kept constant, because when all the productive variables getting compromised and still the stress, the chronic stress prevails, ultimately the animal will lose their biological mechanism to cope up to the stress, and ultimately the animal will die. In our usual practice, in a rigorous 17-odd experiment, I guess, we conducted in this multiple stress concept, and you can see that the first and foremost compromising comes from the growth, followed by reproduction, then the milk production, meat production, as well as the immunity. And you can see that the incredible publication that has emerged, because I'm not showing here that we publish more. It is to inspire the younger generation to show that, and when you develop a concept in science to work, you need to be highly focused, because your concept need to be accepted by everybody. And this is the type of publication you can see that cutting across almost all the publishers, we got it through our concept of multiple stresses. In fact, my mentor also at Australia, when I went for a postdoc, they also did the same experiment with us, and then collaborative mode we published. You can see that the number of publications that has emerged from this concept. Well, coming to the second part of the discussion, how the animal try to adapt. I've already explained. These are the things currently NINP is working with: behavioral adaptation, physiological adaptation, neuroendocrine adaptation, blood biochemical response, metabolic adaptation, cellular adaptation, molecular adaptation, and morphological adaptation. What we are trying to do is that we are trying to develop a score wherein we pick some important biological marker from these responses, and we wanted to segregate them and keep it safe, because that's where we are working towards taking very advanced molecular biological tools, as Professor Madan was addressing in his lecture. We are using those tools to identify some reliable, quantifiable biological marker, so that we can go on a policy maker angle for a breeding policy refinement in the future. That is what we are currently working under the leadership of Dr. Raghavendra Bhatta, my honorable director of my institute. And this is the THI index, which is generally used to quantify heat stress response both in sheep and goat. And you can see that towards my left is the equation wherein we substitute the temperature in terms of degree Fahrenheit. Towards my right is the degree centigrade. And you can see that the range of values: below 82, absence of heat stress; 82 to 84, moderate heat stress; 84 to 86, severe heat stress; and over 86, it is extremely severe heat stress. Like that, the second equation for the degree centigrade as well goes like that. So today we talk about THI index. We don't talk about only the temperature. We talk about THI index. We want to go one step further and say that, is it THI the foolproof index for quantifying the stress response in the animal? The answer is no. But then it could be a reliable indicator for us currently. But then the way forward for researchers like us is that, because the drawback of THI is that it do not take into account the solar radiation as well as the wind speed, which are two very cardinal weather variables which could influence the stress response of an animal quite enormously. And the second drawback of the THI is that it do not measure how many hours of duration in a day the animal are exposed to severe heat stress. So this is also could be misleading at times. So what happened is that I'm fortunate enough to work with Professor John Gogan from Queensland University, Australia, for my Endeavour postdoctorate fellowship. He developed a heat load index, which is called as dairy heat load index, which takes into account the black globe thermometer reading, which is taking into account the solar radiation as well. Of course, in their equation, they use the wind speed. What is this accumulated heat load index? That addresses the second drawback of the THI index, wherein if the unit segregates and then comes to an quantum, and it continues prolongedly for how many hours in a day, then we can easily calculate how many hours the animals have been exposed to severe heat stress. This is the equation. When the ambient temperature is 22.2 and less, the first equation goes with. When the ambient temperature is above 22.2, the second equation. You can see in the equation, it is wind speed is already included WS, whereas the black globe thermometer reading is used to take into account the temperature as well as the solar radiation. Well, if the cumulative unit of this equation comes to 75, then it is called extremely severe heat stress, and you can calculate for how many hours in a particular day it is above 75, then you can claim that many hours the animals are exposed to extremely severe heat stress. DHLI stands for Dairy Heat Load Index, which developed by their team. Well, this is another important methodology wherein we try to identify, the core body temperature. Okay, people are now looking forward to, with the advancement of technologies, to find ways and means to quantify accurately the body temperature of the animal. This is the rumen temperature measurement. You can see that rumen bolus gun, which we are using even at NINP. Currently, we are having this technology. You can see these are the boluses, which comes with a unique identification number, RFID based methodology that this works with, and overnight you incubate them in 37 degrees centigrade and insert into the cattle, and then it will go and sediment in the rumen, and then it can give signal, and then you can capture that in the laptop using, and then record every 10 minutes you can record the temperature of the animal. And there are very strong correlation with the rumen temperature, with the rectal temperature, and then our mentor there at Australia proved that it could be a reliable indicator for reflecting the core body temperature. This is another methodology where we are working even at Australia, and currently at NINP also we are having infrared thermal imaging facility. You can see that now the world is looking to quantify the stress response in a multi-dimensional way, and you can see this is an eye temperature, which is considered a very, very crucial indicator for reflecting the body temperature. And you can see that this is the two different breeds from Tamil Nadu we have compared. Just this experiment got concluded 15 days back. You can see that the eye temperature of the Kaniyadu is more than the Kodiyadu, and also the body temperature of different body parts also projected that Kaniyadu was having a higher body surface temperature than the Kodiyadu, and likewise the feet. It also an important morphological characteristics the animals adapt with, because the goats are the ideal climate animal model. They are found almost in all the tropical countries of the world, and you can see that their legs are very long, and even their in an effort to prevent the ground radiation hitting them, they develop these morphological characteristics of the leg temperature. So we can program all these things, and then we can come and predict their accurately how the animal try to adapt themselves behaviorally when they are subjected to the heat stress using the thermal imaging facilities. And this is the roadmap we are projecting to the audience, that what are the ways and means to tackle the issue. And now it is having an impact. So now how to ameliorate the condition. So these are the 4 different pathways we are projecting to the audience. First is the shelter management or the animal housing management. Second is the nutritional intervention. And then the third is the animal disease management. And the fourth one is the genetic modification, probably to identify a better thermotolerant breed. In the first pathway, shelter management, there are a lot of studies have taken place. I'm not going into the detail. Primarily, this is to provide a clear-cut, suitable microclimate for the animal for its normal performance. Provide shared structure and keep the shed in the east-west orientation. Provide lot of shade structure around the building, and provide cooling systems and forced ventilation. These are all the type of ways by means you can tackle the issue to provide them the microclimate, very suitable microclimate for the animal to survive. By far, a lot of research have taken place on the nutritional intervention, particularly season-specific feeding, fiber feeding, feeding fats and concentrates, vitamins and mineral supplementation, and providing cool drinking water. These are all comes under the nutritional strategies to provide them the comfort and reduce the oxidative stress, reactive oxygen species that is being produced, and then and meet the micronutrient requirement of the animal, so that the animal can perform optimally even during the stressful condition. By far, a lot of research need to happen, and we are one of the team at NINP working on this particular aspect of trying to identify different biological marker using genomics and proteomics approach, and then probably with the way forward when I wanted to retire, I wanted to just use these markers. That would be a dream come true, to evaluate a breed which could adapt and produce optimally to any given agroecological zone. That's why the roadmap for the genetics and breeding. And of course, there are very limited, like that of water stress for animal disease relating to the climate change is also very less reports are available in Indian condition. So it's a way forward for some of the students who are sitting here, budding students, that what is the roadmap goes for animal health management, monitoring and control, epidemiological surveillance, and then rapid investigation of the disease outbreak, particularly the vector-borne diseases, and then linking it with the geographical information system probably will help us to tackle the issue more effectively. Of course, it has to be followed with a lot of laboratory and field researches. These are the different strategies that are being projected to sustain the livestock production in the changing climate scenario. Well, these are some of the easy to use, farmer-friendly technologies, use of fans, wet gunny bags in the wind direction, which could keep at least 2 degrees down in the shed, and growing vegetation over the roof, and there are mist coolings that are available as well. And during the cold protection devices, some of the easily to use, where Nakvi sir and myself were working at the Abhikyanagar, you can see that you can because in the lambs particularly there will be the lambing is in the winter season, more mortality will be there. So to prevent them from lamb mortality during the winter season, so we cover them with the bamboo dome shaped structure, easy to use at the farmer field. And this is the second picture is the thermocol roofed house, wherein you have painted with the light colors to reflect the solar radiation, and the thermocol roofed house. And the Nikra project we have done this, and there could be 3 to 4 degrees centigrade difference in the inside, and this is all being effectively used by the farmers in the Rajasthan. And this is the drinking water temperature measurement. This is another important strategy. In the water trough, these sensors are kept, and they will be sending signal to the laptop. With the software, we can identify what is the temperature of the water, and you keep pumping the cold water, because the animal during the summer season, they prefer to ingest large volumes of cool drinking water, preferably 15 degrees centigrade is the ideal thumb rule people follow. So these sensors will be helping us to maintain the temperature of the drinking water for the animal. Of late, there are a lot of reformations are taking place to tackle the issue of climate change, and you can see that natural light producing, less stress, more poultry, and this is the more yield through biologically effective light. It is a luminous light which works on the blue wavelength predominantly, and there are reports in pig, cattle as well as in the poultry, and these natural lights are bringing in more production per unit of feed consumed. So this is also we wanted to try in our climate chamber, so we are trying to do it a little bit of work on this aspect currently. And this is for the cattle again. And you can see that this is an integrated model extension system, because you talk about doubling the farmer income, and you talk about securing their livelihood. How to do that? Because the farmers have to be given multiple ways to do that, to meet the requirement during the scarcity period. And this is the unit wherein at Kerala it has been developed, and you can see that it has an azolla tank, layer unit, grower unit, rabbit unit, goat unit, and fodder production. So these all together can be a very good alternate livelihood option. Even one enterprise fails, the other could come in handy for the farmers to use it in the farmer field. It's been effectively used in the state of Kerala. And even the genotype differences in adaptation, this is another important area where me and my team are currently working. There are 3 different breeds, where the way forward is that goat is the ideal climate animal model. The pasture lands are shrinking, and then there are a lot of nutritional stress that are happening. And with the largest livestock population India is holding, where is the way to feed the large ruminants? It's going to be very difficult by 2050. So it's high time that the policy makers need to think in this line, because these are the species which is where to go, the sheep and the goat, particularly the goat, because for the various reasons it has a natural mechanisms which can help, which can place them better suited to adapt than any other livestock species. So we have taken this concept now like that of multiple stress, and we are working now. We have, for an initial experiment, we have taken Osnabadi from the Maharashtra, Malabari from Kerala, and Salem Black from Tamil Nadu. And we have worked. The idea is to identify which breed can survive better at Karnataka, because these are 3 state breeds we have brought in, and then because we wanted to identify the best breed in southern India which could be surviving, cutting across agricultural zone and producing optimally. With that intention, you can see that these 3 breeds, although the respiration rate is higher in the heat stress group in all the 3 breeds, the Salem Black breed showed significantly reduced as compared to that of the Osnabadi as well as the Malabari breed. The level of respiration rate or the panting score is lesser in the Salem Black breed. Likewise, the rectal temperature also lesser as compared to that of the heat stress group of the Osnabadi and Malabari. And you can see that plasma cortisol, which is a very important stress marker, you can see almost negligible difference between the control and the heat stress group, whereas in the Malabari and Osnabadi there is increase in the cortisol level, mean to show that the other 2 breeds are, although they are indigenous breed, they are still not able to adapt to the heat stress. well effectively. This is the muscle HSP70 expression pattern. You can see again the similar pattern. Wasp body heat stress group showed highest expression pattern, whereas Malabari heat stress group and the Salem black heat stress group also in the order. Although the expression patterns are significantly higher in all the stress groups, still the Salem black group produced very limited level of HSP70, mean to say that the quantum of heat stress experienced by the Wasp body and the Malabari breed may be considered sub-threshold for Salem black breed, because they were able to quite effectively counter the stress. And also you can see that peripheral blood mononuclear cell HSP70 also almost negligible difference in the Salem black breed as compared to that of the Wasp body and Malabari, where the HSP level was increased. This shows the extreme adaptive potential of the Salem black breed. And with that intention in mind, even Professor Madan was addressing the rumen microbes about we need to go forward to identify some novel aspects, how to quantify the stress response or how to identify the climate resilience in the animal. This is the way forward. We started an experiment, and it's a very good experiment. We found some very good microbial diversity identification. You can see that this pictorial representation, the Firmicutes, Proteobacteria and Bacteroides were predominantly the major phyla that has been obtained, and among that you can see that the Salem black have a little level of lower level of Firmicutes, because they are also hydrogen producing bacteria, and what happens when the hydrogen is produced more, it could culminate in the more methane production. So like as a result, you can see that in the heat stress condition it is significantly lower. Likewise at the genus level also, there's all the various diversified effect we got. I'm not going into the detail due to paucity of the time, and you can see that the Privatella, which is significantly higher as compared to the Wasp body and Malabari, because they are very good. They play an immense role. Almost all the metabolic activity they control, and the amino acid metabolism, the nucleotide metabolism, and the fat metabolism in an effort. And also the Psychobacter and the Privatella, they all have been tipped to be playing a role for very good degradation capability. In terms, you can say that they have a better digestion ability. That is how the Salem black breed we are performing at that level also. This picture will clearly say why Salem black is better. You can see that the significantly abundant microbes that we have grouped them in the Wasp body, Malabari and Salem black breed. By grossly, you can see that at the phyla, class and genus level, the Salem black showed the least diversity, means the less abundance, which shows that their microbial compositions are intact and they are able to do the normal digestion and then produce optimally. Because we conducted this experiment, I'm not present at the detail, where the growth, their reproduction, their meat production, and their adaptation, and almost their rumen metagenomics, and then the transcriptomics all points towards that Salem black is a better breed. I ask a question to the audience, is that if a farmer of Karnataka, why he needs to use the other breed, why not the Salem black breed, which has the immense potential to survive in different agroecological zone and produce? This is the way forward research. Again, you can see that this is the KEK pathway. This is the various pathways that has the rumen microbes associated in the rumen fluid. You can see that in the Salem black breed, the last group, all these pathways of metabolism, genetic information processing, environmental information processing, cellular processing, and organismal systems, all are significantly lower as compared to the Wasp body and Malabari breed, mean to show that they have the inherent ability to alter the metabolic activity in an effort to cope up to the stress condition. And we concluded from that experiment, sustaining livestock production in the changing climate scenario requires efforts to identify best indigenous breed to survive in different agroecological zone. The significantly lower respiration rate, rectal temperature, HSP70 gene expression in the Salem black heat stress group animal compared to the Wasp body and Malabari group pointed towards the better climate resilient capacity of the Salem black breed. Therefore, promoting the Salem black breed among the local farmer may prove beneficial to ensure their livelihood security. Well, you can see that like that of multiple stress concept, this is again to the students and the youngsters who are sitting over here to inspire them from this single experiment, see the quantum of publication that has emerged. This is in the meat science I was talking about, and this is again in the biological rhythm research, Journal of Animal Physiology and Animal Nutrition, again biological rhythm research. You can see that International Journal of Biometeorology, resilience of 3 indigenous goat breeds to heat stress based on the phenotypic traits, and peripheral blood mononuclear cell HSP70 expression, and again one more publication from biological rhythm research, again molecular biology report, expression pattern of candidate genes reflecting the growth performance of goats subjected to the heat stress, and again one more biological rhythm research for toll-like receptor pattern expression. And this is an HSP70 expression in almost all productive and adaptive organ. How the expression pattern of HSP70 differs in these breeds, and again the theory-genealogy paper where each stress impact on the expression pattern of different reproduction-related genes, and this is an effect of each stress on the quantitative expression pattern of different cytokines. You can see that almost all in a single experiment we have completed and we have published in very reputed journal, because this is what the world expects from the climate change point of view. What is the way forward research is all about. These are the biological marker me and our team are working here have been identified. These are the toll-like receptor 1, 4, and 5, thyroid hormone receptor, respiration rate, SLICAR gene. These are the various blood biochemical markers like PCV, hemoglobin, HSF1, HR factor 1, and other HR proteins. From the skeletal muscle, it is a superoxide dismutase and glutathione peroxidase and nitrous oxide synthase. There are various enzymes you identified from the liver, which is having a thermotolerance role, and from the skin, prolactin receptor gene and fibroblast growth factor. These are the various biological markers we are working, and we are further refining through transcriptomics and proteomics approach now. And this is again an invited review where all these data are pooled here. Genes for resilience to heat stress in small ruminants, a review. So this as an all the identified biological marker from our team, we used only our references for this particular because it is an invited review. I'm also happy to share with all the physiologists that I've been selected last week as the associate editor in small ruminant research, and I would urge all the people who are working on the small ruminant, please submit your articles for this journal. And this is a prediction model what Professor Madan was speaking about, the molecular tool. The prediction models, assessment methodologies, and biotechnological tools to quantify heat stress response in ruminant livestock. You can see one of the highest cited review now we have attempted on this. Almost all the important tools of genome-wide association study, and then epigenetic studies, and then the other transcriptomics and the next generation sequencing, all we have addressed in detail using this technology in this review paper again. And this is the roadmap or the FAO projection adaptation strategies for the small ruminants breeding strategies. Evolve an animal with a good genetic potential for producing and adapting optimally, strengthening the meteorological services. This is very vital. We need to strengthen our meteorological services and water resource management and disease surveillance measure. There are a lot of scopes to improve on the disease surveillance measure, particularly linking into the climate change. Early warning system. You know that 98% of the affected population are due to climate change is from the developing part of the world because we don't have good early warning system. Need to be spot on. And women empowerment. Women are better manager. We need to bring in those group for the upliftment of the animal kingdom, and also the strengthening the extension services, which is very vital. We are working a lot in the laboratory condition. Of course, to take the technology from the lab to land, you need good extension system in place. Otherwise, the purpose gets beaten up. And most importantly, already Professor Madan had detailedly explained the capacity building program for various stakeholders involved in climate change research is the need of the hour currently, where ICR taking a greater inroad in terms of sponsoring winter schools and summer schools and short programs for tackling this, and then training many people who are trained abroad, and then they come and deliver talks and train these personnel for coping the livestock production with the changing climate scenario. I'd like to conclude my talk by saying that research aiming at improving livestock production under the changing climate scenario should aim at countering multiple abiotic stress rather than individual stress. Sustaining livestock production also in the changing climate scenario must target on improving the production efficiency through strategical intervention to augment livestock production. Most importantly, indigenous animals need to be targeted, and then more such indigenous animal population have to be tested for their climate resilience, and we need to identify a pan-India breed which could survive and produce optimally in any agricultural zone cutting across the country. So that is the most important point to take it from this talk. And the future perspectives way forward, we need to develop advanced thermal devices to quantify more accurately the temperature, the heat stress condition of the animal, and strengthening the agro advisory services through the WhatsApp or other technologies now currently available for the farmers to prepare them well ahead for the devastating effects, and involving nutrigenomics, metagenomics, and epigenetics. These are all the science that is emerging in the adaptation pathway, and particularly the epigenetic, because the animals have evolved over generation after generation, these adaptive potential. You need to study these in an effort to quantify ideal biological marker, particularly the DNA methylation pattern difference and histone molecule modifications are all happening. We need to identify those markers which could reflect the generation to generation changes that has happened. These animals have evolved over the years to gain this genetic potential of coping to the adverse environmental condition. Of course, more refinement have to be happening on using the advanced molecular tools, particularly the genome-wide association studies to quantify advanced biological marker to go on a breeding policy, and also immunization, the vaccine production for less methane. Also, Cyro at Australia have attempted, and a lot of attempts have been made, even in India. We literally failed because the feed resources primarily determine the microbial population, and the vaccine do not work even in a 30-kilometer periphery. So this is very vital that we need to try and identify an appropriate vaccine which could be used cutting across the feed resources for the animal, probably the way forward again for small ruminant production. And most importantly, the climate smart sheep production, as Professor Madan was talking for the dairy cattle. And it is very essential that we need to have good preparatory system to tackle the issue, and then good adaptation and mitigation option to counter and then ameliorate the condition in the animal for their optimum production. Therefore, this is the way forward we are projecting to the audience. The breeding policy have to be relooked or revisited. The new breeding policy projection is that the traits predominantly should not be an production trait. It should be an amalgamation of production traits, adaptation traits, and low methane emission traits. This is the way forward, particularly for our team under the leadership of Dr. Raghavendra Bhatta. We are working on this concept now currently to pass the way forward for us at NINP. And a proud moment again for Professor Sagar Sanyal that this is a way forward for me, and it's a lot of hard work have gone into place. And with my postdoctoral experience, we have opened this center at recently last February. Our Honorable DG Dr. Thirochan Mahapatra himself was the chief guest to inaugurate the facility, where the Center for Climate Resilient Animal Adaptation Studies we have developed for the small ruminants in particular. And you can see that the setup is that it's the first of its kind in Asia, because we don't have a thermoneutral zone climate chamber. For example, in the climate in the summer condition, you can see that you keep the control group in the shed and then expose the animal in the outside environment. But even in the control group, you can see it will be 38. Outside it will be 40, 41. So it cannot be an ideal control. If you are trying to identify biological marker, it's very vital that the animal need to be in thermoneutral zone. That is where towards my left, that is called as a thermoneutral zone, where we have a dual animal holding facility, where we can induce 24 degree, which is the ideal thermoneutral condition for the goat or sheep. And towards my right, it is the heating or cooling chamber. Both heat stress as well as cold stress experiment can be conducted, which has the temperature alteration from 5 degrees centigrade to 50 degrees centigrade with a relative humidity of 0 to 100% alteration. So this is very vital and way forward, because we wanted to conduct more rigorous study in an effort to identify more biological marker, and at the same time nutritional intervention studies for ameliorating the condition as well. And there is individual feeding and watering facility, individual urine and defecation collection facility, and we are also having other thermal imager and infrared thermography. Everything we are in place, and there are also the motion sickness camera, where we can record completely the behavioral response of the animal. Even this is also avoiding the social stress. That also is brought into the concept, because animals need to communicate with each other, and they will not need to have a free movement space in the chamber to prevent them from the restraining stress or from the social stress. So all these factors are taken. It's first of its kind. Even my Australian collaborators have come for the inauguration. It's a proud moment to share with all my teachers, because a lot of hard work have gone into last 8 years of my service. I've gone into this to bring into this reality, and we have already culminated our first experiment in this. And this is again an important point to discuss with the audience, because this is again a proud moment being a physiologist and taking a blessing from Professor Madan, because very rarely I interact with him. So like you can see that this is the platform wherein we have published 3 Springer books: Environmental Strength and Amelioration Livestock Production, Climate Change Impact on the Livestock Adaptation and Mitigation, and Sheep Production Adapting to Climate Change. Because as a request from the publisher, I need to propagate it in all my lectures, and that is what we are first in the world to bring in 3 international Springer books on this concept, and we are already in the process for the 4th one. You all can predict quite easily what is going to be the 4th. It is obviously the goat. The goat is the way forward, that climate animal model to go for that food security point of view. Keep in mind that it's going to be the species way forward for India also. Like goat has to be concentrated more. That's where we have been given the mandate by the ICR that we need to screen all the indigenous breeds of the country and to come aboard and develop a pan-India breed which would produce optimally and adapt well and emit less methane emission. That's what the way forward for us. And these are the professional affiliation membership available free of cost. I've already shared the PowerPoint with Professor Das, who will be sharing it with all the participants. The details are there for especially for the students. You can be an active member in this for developing your professional network. This is the free membership, particularly most all from international societies offering free membership for the developing country people. Well, special acknowledgement to the my teachers, Professor P.K. Das as well as Dr. Ghosh, who played an immense role in shaping up my research career. Also, I would never like to forget the contribution made my major advisor, Professor Sagar Sanyal, who has been in my strength when I started my career in veterinary physiology at West Bengal. And always, even in last year, I've been there to donate all my 3 international books for the library, for the institute, because I always have a special place in my heart for that. And thank you so much for giving me this opportunity to share my small research finding, because half an hour to 45 minutes is too less a time for me, to be very honest, with the quantum of data I have generated over the year. And I think that I have opened up the topic for the audience. We will be very happy to collaborate, and we will be very happy to help the youngsters, because you can see that this is on the team. It is a team effort. Both my previous institute director, Dr. S.M.K. Nakvi, who have also mentored me quite effectively at the ICR, and currently Dr. Raghavendra Bhatta, who is my pillar of strength, who is supporting me as always. My international collaborator, Professor John Gogan from Queensland University, Professor Frank Dancia from University of Melbourne, he was there for my inauguration, and Professor Michael from Charles Studd University. And these are all my fellow colleagues at the NINP, and most importantly, my students, because without my students, I am nothing, because these are all 18 hours of hard work per day, last 8 years or so, to bring this research output. And I'm proud to say that most of them are placed at abroad for the PhD with a quantum of publication we have brought in, and that is to inspire again for the student, not to post that we publish more or we develop students to send abroad, not like that. You have a vision forward and then work towards the goal, and I think everything is a possibility in this world. So that is what we are trying to be an example for that. Thank you so much for the patient hearing, and any questions I'll be very happy to answer. And this is my email ID and phone number. Feel free to contact me for any type of help. We'll be very happy to do it for you all. Thank you so much, sir.
Thank you, Sejian, for your nice deliberations. A vibrant speech you have showed us, and particularly the mitigation strategies which you have mentioned at the message slides. It's very important that agroecological zone-based climate resilient livestock breeds should be developed. So it is very important for us in this crucial juncture. Now I am requesting Dr. Ghosh, if you have any specific question, because already we are running late, around 50 minutes from this scheduled time. So very specific 1 or 2 questions, please.
Thank you. Could you hear me? Hello?
Yes.
Yes, sir.
Is it audible? Okay.
Yes.
Okay. Thank you, Dr. Sejian. It's nice. I'm proud of you for your excellent lecture and your feat you already achieved. So already some questions are there, and there are a lot of questions actually, but all questions are very good and relevant. But I'm asking only 2 questions, 1 or 2 questions. Okay, please try to answer in brief. First one is that animals in arid and semi-arid regions usually encounter heat stress during summer seasons.
Yes, sir.
What is the extent of production loss occurs during summer seasons versus winter season in these regions? Do you think nutritional management can fulfill the productivity occurring during summer season?
Exactly, sir. It's a very, very pertinent question. I would like to answer it in a different way. What we did in an experiment was when you are not compromising the nutrition, because the animal first try to reduce the nutrition to cope up to the heat stress condition. When you are not, when you are trying to compensate this through the split feeding, we did an experiment excellently. We don't feed the animal. We feed them around 5 o'clock in the morning and after 6 p.m. in the evening, and we give them some nocturnal feeding as well in the midnight. So they compensate for the intake loss during the daytime, because they try to avoid the metabolic heat production to coincide with the peak temperature during the daytime. So we did that experiment. We identified that there were any production loss at all, because when we are doing this, simple nutrition management strategies, these Malpra breed are extremely adapted breed. They were, when the nutrition was not compromised, they were able to counter heat stress quite effectively. That is what the conclusion. Well, to answer your second question, second part, that between the winter as well as the summer season, in the summer, the impact on the production loss was more as compared to that of the winter. I can say that me and Dr. Nakvi worked out the economics as well. 37% of the production loss has incurred even in the indigenous breeds.
Okay. Thank you. Thank you, Dr. Sajian. Now I have another question. Now, what are the basic parameters to be used for estimating and ranking of thermo-adaptable goats? And what should be their threshold values? If you have
See, like you need to develop a score sheet now. Like we are also developing such a thing. It cannot go with a pinpointedly 1 or 2 markers or something. You need to have a very good setup of physiological trait marker, genetic trait marker. As of now, I can say that we are using respiration rate, rectal temperature, and head temperature, particularly the eye temperature, as well as the plasma cortisol and thyroid hormone, especially the T3, not the T4. The T3, we call them as a very good, because cutting across any temperature differences, we have identified them as the marker. And most importantly, HSP 70 and HSP 110, along with the heat shock factor 1.
Okay. Okay. Thank you, Dr. Sajian. And thank you for your excellent talk and excellent response. And a lot of questions will be there. I shall send it to your mail for your detailed response.
And the email ID has been provided to them. In fact, I have already shared with Professor Das, and he will be sharing it with.
No, actually, it is with me. I need not tweet it. You are already in my mail. Okay, then we can send this thing. Thank you. Thank you. Now I'm Dr. Das, please.
Yes. Thank you, Dr. Sajian, for your nice deliberation. Actually, what you have learned during this short period of time, in your lifetime, your experience, is very difficult to deliberate within this short period of time. However, you have discussed in well manner, and I think all the participants are satisfied about their expectations regarding this specific issue for the this climate resilient system of production. So I think that today we may conclude our discussion. It is very resourceful discussion we have made by our Professor Madan sir, then after Dr. Sajian. Tomorrow we have the 3 sessions. Our first session will be started at 2 p.m. Our Dr. D.N. Kamla sir will discuss first regarding the methane gas emission in the livestock production scenario, and followed by there is a second session will be Dr. Professor L.K. Babu, Dean College of Veterinary and Animal Science, OUT Odisha, and the third session will be delivered by Dr. Deepak Banerjee, the climate stress production system in the Sundarban area. So I think our participants will be enriched more in our second day discussions. Now today we conclude our entire discussion of the first day. Okay, thank you very much for your nice participations and deliberations and interactions, and all the participants who be with us around 1 hour delay from the scheduled time. Very much. Thank you to all.
Thanks, Das.
Thank you, sir.